Welcome to class 3. This is the third and final class for the webinar folks. And we will continue on with the in-person folks throughout the end of the year. Just wanted to, a couple logistics before we get started. For the online people, Laura's going to pop some things in the chat to help you with those logistics, popping out screens, raising hands, chat, Q&A, and all that. So she's going to put that in the chat for you to read and kind of reorient yourself. In-person folks, I don't think you need reoriented. You're all here, you know where everything is. Let's see, today we have a couple of breaks. We'll have a break around 9:30 and a break around 10:45. The goal will be about 10 minutes. And then we will end promptly at noon. Looking at you instructors. Just kidding. We're gonna end at noon. There'll be lunch for the in-folks people afterwards. Any questions before we get started? Comments, concerns? Celebrations. Okay. We had sent out some feedback, some survey for feedback. Thank you all for those of you that participated. Val, did you want to mention anything about that survey and feedback at this point? I am ready. Oh, please take away.
I just wanted to say thank you to those virtually and those in the room for giving us feedback. Just wanted to highlight a couple of things that we heard you guys say. Especially those that are going to be in person, because I think it's important to make sure that you know what is to come. I think what we heard from those in person is that you definitely want to see more examples. The examples really help to kind of take the concepts home. And you will be getting a lot of that in our next 6 classes. You want to be given examples of failures, of previous structures. It would be interesting to see how the 5 elements can anticipate or fails to unforeseen circumstances and potential failures. You also want to learn more about the weaknesses of the 5 elements and how they may result in failure. And so appreciate you putting this out. That gives us food for thought for the remaining 6 classes that we're going to have. But I just want to say that the remaining 6 classes are project-oriented, applying these concepts that we've been talking about the last 3 classes. You want to know how to apply geomorphology more directly on projects. You want us to speak to stormwater and water quality features, maybe touching on full spectrum detention and even the spec sheets and how they're used. And then how all this helps to meet NS4 requirements. Looking at you, Ryan, because I know we talked about that last year. There was one regarding, well, how does this shape or influence criteria and planning? And hopefully we'll touch on that a little bit. Mary, there was some chat about what are some common native plants for streams and waterways in differing water regimes. So some discussion about that. Geomorphology and steep mountain streams. So I'm curious to see where that comment came from and what steep mountain stream we might be working in. And then water management, water conservation, water management for existing urban areas, retrofitting, and what plants look like in these environments. So these are all really, I just wanted to see if there was anything else worth mentioning. And again, there was a general comment of this class continues to be high level, these last 3 classes, and would love for it to get into the weeds, the nuts and bolts of how to really apply the 5 elements. I just want to emphasize that is what we're going to be spending the rest of the 6 classes. Just wanted to draw that out for those that are wondering. The first 3 classes is intended to cover concepts, and we're going to be working on applying the concepts in the nuts and bolts form for the next 6. And you're actually going to see projects. You're going to get a chance to work on project activities that apply them.
And that's just for the in-person folks.
This is for the in-person, and then for those that are virtual, again, just do really appreciate your feedback. This will help us to inform future webinars that we put on. I think the big thing that you pointed out is engaging you even more. It's drawing you into the conversation and helping you to be a part of the conversation. There was a little bit of an audio quality issue last time, and so please do chime in. If you're struggling to hear us, put it in the chat. We are monitoring it so that we can make sure that you can hear us clear, because if you can't hear us, it's very hard. That was really the big one that came. And the other one that some of you mentioned virtually is gosh, would love to get to some nuts and bolts of the concepts we've been talking about. And we'd love to, it's just virtual is not a great environment for that. And so if you're interested in the nuts and bolts application of the 5 elements, encourage you to participate in in-person classes at the Screen Management Academy. Laura posted the interest form last time and she'll post that again this time. So if you're interested in applying the nuts and bolts, please sign up and eventually you'll make it into the in-person class. Just wanted to share that feedback. You're going to get another survey today. And for those virtually, that'll close out our webinar series. For those that haven't provided comments, would love to hear from you so that we know how to improve the webinars in the future. And then in person, you will be receiving a feedback form every class because it's very important that each class is adapted to kind of what you're saying, what is working or what is not. So again, please just give us 5 minutes of your time. That's it. Thanks, Kristen.
Take it away, Jesse.
I thought you were gonna say something.
No, I didn't have anything to say. We're gonna do a quick recap and then talk about today and what we're doing. So we had to quite plan this transition, so it's a little,
Yeah, it's.
there's your pointer. Thank you.
Okay. How many of you are sitting in the same table that you've sat in the last 2? It's pretty good. You guys mix it up. Good. Same chair. Just Andy. All right. Well, I have the distinct pleasure of walking you through time here the last 2. I'm just gonna do a very quick.
Link, link.
We're gonna do a quick recap. To walk you through what we've done. There we go. No. But this is a great slide. So just sort of recapping the first class, we were really trying to introduce just the idea of what do we mean when we're talking about natural systems. And then the second class being about urbanization, third class being about planning. I'm just killing time. There we go. That's for natural systems. That was really well done. So these are the 3 things we covered. So hopefully some version of this looks familiar. I had a version, Ryan had a version, we ended up going with Ryan's version. Ryan's version. But hopefully this looks familiar. Just the cycle of what happens with water. All flows, everything's important. We've been talking a lot about the difference between considering just the 100-year event versus everything else. So thinking about what base flows mean versus those big flows and everything in between. And then in terms of ecology, is it correct for me to say the ecology? Hopefully you're all saying no, because Mary hammered on you for that one. But just thinking about how ecology fits into the urban systems as opposed to where it is on the spectrum of the transect. I love this slide because this one to me always brings me back to, especially in urban areas, we always seem to be striving for that climax community. We're always trying to have really nice, big, healthy, mature trees, this great understory, all of that stuff. And the reality is that this process, if it was left to nature, would take hundreds, if not thousands of years to really get to that. So we're always really kind of trying to keep in check the reality of trying to get to what we have our mental model doing. Any thoughts or ideas on class 1? Then class 2 was urbanization. So we were talking about the transect and in particular, when things are urbanized, the kind of natural processes, especially riparian, those associated with the riparian areas, sort of get displaced. Sometimes they get completely removed. And so the idea of how can we think about ways to integrate the functionality of riparian systems. And then hopefully everybody can make their way through a hydrograph now and understands the system in terms of when we're urbanizing, the difference in what we're doing to the hydrology and the hydraulic factors. So we're really shooting for something that looks more like that green, even though we're forced into managing something that looks like the blue. And when we're working across that transect, this idea all the way to the left, that wild or natural zone. But when we get into those more urban zones, I love this image on the right. When we get into those, you notice that there's just a lot of different conditions that we're dealing with, but it doesn't mean we can't work within that system. And this, you all can see it, this diagram that Ryan put together that just illustrates all the different ways that water is moving through the system. And the things that some of them we just don't think of, like evapotranspiration and interception and all of those kinds of things. But when we're controlling these systems in urban areas, we're not necessarily getting groundwater recharge and all of those kinds of things. So really figuring out where it goes and what those impacts are. And then who can name this? Lane's balance, good. Hopefully you remember that Lane's balance is really, these are some of those knobs and dials that when you're increasing flows, increasing steepness, increasing all those kinds of things, sediment, size, they are all moving all at once. There is not really one dial to switch things on and off that fixes it. It's really constant in terms of when you move one thing, another reacts. Who remembers the main point on this one? I'll start it with safe, fail versus fail safe. That's right. So when we're thinking about that concrete trapezoidal channel, right? LA River, places like Harvard Gulch, there's all these things. Those are with the intent of being that safe or that fail safe, right? But when they fail, it can be really catastrophic and can be very expensive. And so if we can move towards a safe fail, where when it fails, it's not that big a deal. Maybe it's going to require some maintenance or some repairs, but we're not talking about catastrophic or safety or life safety issues. And then it's all about context, right? Like we're always considering that our improvements and our planning should be fitting into, if there are master plans out there, if there are vision plans, if there's a development plan, we're always thinking in the back of our minds how we're fitting and dovetailing all of these different strategies into the context. And it really does depend where you are on the continuum. Any other thoughts? Okay, today we're going to talk about planning. So we're going to try to think a little bit about taking some of those things that we've been talking about, what's important about when we're moving forward, making space, all those kinds of things. And Brent's going to take it off. Ryan. Right? Working to nature. All right.
So we'll touch on looking to nature. We'll look at how we shape tomorrow, always thinking ahead. And then Brent's going to go through dynamic teams a little later this morning. So I showed this slide last time. The intent here was, we were kind of talking about criteria, how criteria is implemented, how I have a love-hate relationship with criteria because sometimes it feels too confined and constrained, and not the intended purpose, which is more or less to be guidelines, is to guide you in the direction that we're heading. But I wanted to go into this a little bit more detail, looking at LID, which we talked about, low impact development, MDCIA, minimizing that directly connected impervious area. And, when we're talking about urbanization or redevelopment projects or anything like that, like Jesse mentioned, one of the things that we're trying to do is we're trying to mimic those natural processes. So when we say we're looking to nature, that's kind of what we're talking about. We're looking back at how those natural processes work and trying to implement those same effects into our current designs. So part of that is, and I would say probably the biggest one is runoff reduction. And what I wanted to highlight today, especially in relation to criteria, is how that comes across in criteria. Because oftentimes I feel like, as designers, we kind of get into the habit of, we kind of know what we're doing. We're not going back and reading sort of the narratives of criteria manuals. We're going directly to the calculations, the details, the requirements, which I think at times we need to take that step back. And so runoff reduction, this is the first step of the 4-step process. It's in the current Mile High Flood District criteria. It's also a lot of municipalities in the Denver metro area also reference this. I know Colorado Springs and others specifically mention this chapter of the flood district. And the idea, like we talked about last time, is if you can reduce that runoff coming from your site, whether it's a greenfield site and you're developing it or urbanizing it, or it's a redevelopment site where maybe you're trying to reduce your impervious areas from 95% to 85%, that is going to be the first key to, sort of mimicking these natural processes. So, the question being, how can we use those fundamental transport processes to our advantage? And what are those, when I say the fundamental transport processes, what are we talking about? Jesse had showed a slide that had all of them on there. From hydrology.
Evapotranspiration, infiltration.
Yep. Evapotranspiration, infiltration, runoff, all of those things that change as we urbanize or as we change a site. So reducing runoff, and so this again highlights that when we're looking at reducing runoff on a site, we're really focusing on the peak flow reduction. So in that hydrograph, it's bringing down that peak of the curve. There's the volume management. So the area under that curve in the hydrograph, trying to minimize how much volume is actually being shed from the watershed. And then it's the water quality improvement, which is not just, water quality capture volume or treatment. It's you get water quality benefits from just allowing water to move over vegetated areas. So, when we think about water quality, it's not just the formalized version of a treatment facility. And then the other thing to highlight here is, and Troy talked about this, is it's not just those large storm events. So when we're looking at reducing runoff, it's not just the 100-year. We're looking at the small events, the water quality capture volume event, which is only like 0.6 inch of rainfall. Those minor events that we can really distribute and move throughout the site and manage. And so when you start reducing runoff and you're taking that holistic approach, I've listed here just some of the benefits that you start getting from that. You get better site aesthetics because if you're introducing more landscape areas, everybody likes seeing landscape and trees and vegetation. So you can better integrate, the aesthetics of it. You're getting functional landscaping, process-based treatment. I'll touch on a little bit more. It's kind of what we call the treatment train. Has everybody heard treatment train or familiar with what that means? So that's just basically, going from the rooftop of the building to the ground and essentially trying to manage and treat the water through that entire system as it goes through. And then, like I mentioned, you're getting the improved water quality, reduced volumes. And then if we do it correctly, and Brent will talk about this during the planning phase, if we do that correctly, we can often increase our functional space as well, because we're using spaces for multi-purposes as opposed to just dedicating one corner of the site for specifically volume treatment or peak flow reduction. And so when we talk about criteria again, one of the things that I recommend everybody do is go back and read through the narratives of your local criteria, because oftentimes, like I said, if you just jump straight to the equations, the requirements, you're missing the opportunities, which are often listed in the narrative of that criteria. And so it talks about in those sections, it talks about routing flow through the vegetated areas, It talks about, reducing your impervious areas, everything that we've been mentioning. And so this idea of, criteria sort of hindering us or confining us, I just urge us to go back and you can actually point to the narratives in the criteria manuals as the criteria, Yeah, Bab?
Oh, there's a question online.
Yeah.
But that's time well, this is a good time to ask.
Yeah.
Right? The question online is if we modify runoff and watershed, how does this impact water rights?
So that is a really good question. I'm not a water rights specialist, but, one of the requirements, especially related to detention, is you can't store water for more than 72 hours. So that's why oftentimes when you're designing detention facilities, water quality facilities, if you're using the district spreadsheets, it flags, it notifies you if you're not draining within 72 hours. And so that's part of the water rights law. What I'm not as familiar about is, one of the things that I don't think has ever been brought up, so I'm hesitant to do it, but evapotranspiration. I mean, if you start putting in, and Mary can chime in, if you, start putting in more and more plants, technically you're using that water, but from a legal perspective, Mary,
Yeah, and again, I'm not a water rights expert either, but I have some close exposure to some of it. Typically, especially with new developments, right, you're replacing vegetation that's already there, that's already evapotranspirating with impervious surface, so a lot of the water right volumes and so forth are calculated from way back in the day. So these things that we're doing with vegetation doesn't get pulled into it. The state and water rights folks are really excited though about new bodies of open water. So that's why we try not to have, back in the day, we used to have wet detention facilities, big old wet ponds. And those, you don't see those anymore because of the water rights concerns. Fortunately, people they haven't gotten too excited about our micro pools. But, when people are getting excited about creating open bodies of water by putting in beaver dam analog, structures, that shows you how sensitive they are. So, but typically extra vegetation is not a problem. Yeah, but avoid those open bodies of water.
I was just gonna say, if you offered a micro brew, we can micro too.
And the micro pool might get people off. It's really good.
Unless you knew what was in the micro pool.
Oh,
Ew.
Less, okay.
yeah.
Micro, but ew.
Mary, is that because it's really hard to quantify that use of water by plants?
Well, no, I would, the question is it because it's hard to quantify? Believe me, there are water engineers out there who think they can quantify everything, so. I don't think that's it. I think it's more just the recognition that we're transitioning from vegetation to impervious. So if you put vegetation back, I think in the law, it's kind of a wash a little bit. That's my generally somewhat informed take on that.
One of the things that I've heard is that we have such a high tan coefficient. What you're doing is you're allowing the water to go up into the air and then it might transfer out of basin by the time it falls again.
Sure, I mean, it could do that, but that's what it's doing. I mean, if we weren't here, it'd be kind of doing that.
Yes, but you're changing the patterning and keep creating
Yeah.
a lot of body.
yeah.
Exactly.
Yeah, the surface area of water bodies is probably the biggest thing that always comes up. So I have several projects right now that are through golf courses, and golf courses have irrigation ponds. A lot of times because they have to irrigate all the grass that they have. And one of the big things is if you're ever modifying those ponds, you have to keep the same surface area. So, you can't add additional surface area because then Dana's point, you're adding that evaporation to from the pond. So, that's just always something, even not being an expert, that's always something to be careful of, is that surface area of existing ponds. Good question. One of the other opportunities here that we talked about a little bit last time was distributing management throughout the site. So I showed the example of all the distributed detention ponds down in Castle Pines. Again, just, to reiterate that is much more beneficial because you have smaller facilities that are easier to maintain, they're easier to handle. And then oftentimes you can design them in a way that you're not having vegetation issues. So we'll talk a little bit, probably in a future class in more detail when we get into using the UD detention and looking at detention facilities. But the bathtub design, as I call it, is very bad for vegetation. You often can't get vegetation established. It often dies. It's a mess. And so if we can distribute detention throughout the site, then we can design these facilities in a way that has vegetation resiliency. The other thing that's really important is protecting existing features that are high functioning within the watershed. So, and this is more the case on either greenfields or some redevelopment sites where you have existing vegetated areas. It's really hard to do that in ultra urban areas like downtown, but the more that you can protect those existing high functioning areas, the better management and treatment you're going to get on site. And so, Mary, how long does it take for vegetation to establish once it's been disturbed if you seed an area? in Colorado?
Just for herbaceous,
Yeah.
not trees and shrubs, you're talking a good 5 years.
Right. So if you can save an area that has been around for 15, 20 plus years, has healthy vegetation, has healthy soils, then you're not having to reestablish, wait 5 years, manage it through your permitting and all of those things. And so it's just any opportunity you have to save those high functioning areas within your site, I'd recommend doing that. So somebody about mentioned the Denver or the MS4 permitting. I wanted to show this as another example of there's criteria out there that actually benefits what we're talking about in this class. And so this is just the runoff reduction standard from Denver's MS4 permit. I think it was within the last couple of years, they added this runoff reduction standard to help with some of the volume requirements during design projects. And so the idea here is if you can show with your project that you're infiltrating 75% of your water quality capture volume, then you don't have to provide the full 100% water quality from the site. There's sort of these various standards within the MS4 permit that you can meet. The very first one is just the full 100% treatment, right? You're required from a water quality standpoint to meet the full 100% treatment. Now they have this water runoff reduction standard where if you can show that you're reducing runoff from your site through infiltration, then it reduces your requirements for treatment on that site. I forget, I think it was you, and maybe in the first class mentioned, in another state, the requirement is that you have to treat everything on site before even allowing it to go off site. So that's kind of what this is doing. It's forcing you, or it's maybe not forcing is the right term, but it's incentivizing you to infiltrate on site and manage water on site as opposed to just putting it in a pipe and sending it somewhere else. So again, look back at your available criteria for your project, because oftentimes there's things like this that you can point to and utilize with your design.
It wasn't me.
Oh, I see. Something popped up. Trying to.
Okay, perfect. So again, resources, utilizing resources. So these are just a few screenshots that I took. There's many more out there, but going back, Jesse mentioned there's oftentimes master plans, reports, things like that have been done that sometimes just get shelved and nobody looks at them ever again. Those are the kind of plans that you should be going back to look at. One, it'll help inform the context of your project, the context of your surrounding area of your design. Oftentimes they've done the thinking through, some of this stuff, green infrastructure planning, all of that sort of has been done to an extent. So you can utilize these resources to help move you along with your projects. Denver has, these are just three of them. I'm sure Jesse can list a whole bunch more, but there's the green infrastructure implementation strategy that they have. The green infrastructure guidelines, so that's where all the details come from street side planters and things like that. The green continuum, which is relatively new that Stream worked on. The one on the far right is from Colorado Springs, so they have developed a new green infrastructure guidelines in the last couple of years. So these are all out there. So again, encourage you, to look through these.
I have a question.
Yeah.
Jesse, the covers on all these look really
Similar.
similar. It's very interesting. I've never put them all together.
You can thank Brian Wellington and Sarah Anderson.
Good job.
They wanted to make sure that was all consistent.
It is.
And the city is updating the ultra urban green infrastructure guidance right now. I don't know when that's gonna be done, but.
Yep.
So they're doing some updates, which is an important factor for what you were describing, going back and making sure that things are contemporary and
Right.
so.
So this is just another example of going back and looking at the narrative. So this is from Castle Rock. And this is just their standard storm drainage criteria manual. But the things I wanted to highlight is one of the first few chapters, sections is talking about multi-purpose resources. So, utilizing your area for multiple reasons. Allocation of space, that's a big one that, we've mentioned here and Troy is going to get into. That's part of this criteria manual, so it's already in there. Volume reduction practices, and then maintenance considerations. Maintenance is a big topic, especially when we start talking about green infrastructure, water quality, all of those things. And so, and we'll get into probably a lot more detail when we go through those example projects that Val mentioned, but maintenance considerations is always a big topic that comes up. And then, so the next series of slides, the image on the left is a sort of cut sheet that Mueller developed for the districts a couple years ago. And what we were attempting to do here is highlight essentially that treatment train and what those practices look like. Again, it doesn't always need to be so formalized within your design. So, runoff reduction practices, what we're highlighting here, and I know the text is probably a little small to see if you're in the back, but you should have this available. You can go back and I can share these cut sheets if people want them specifically to look at, but looking at the runoff reduction practices. So again, that's just minimizing your directly connected impervious areas. So in the photo, you've got various trails, but they're all disconnected by landscape areas. Blue and green roof treatment. Everybody familiar with a blue roof? Do you know what that is? Kind of. So the difference between a blue and a green roof. So the green roof is when you have vegetation and, a lot of times, like in the photos from Seattle, a lot of times people will integrate those into community spaces up, top. But that's where your green roof is. You typically have a section of material that allows for infiltration, the plants use it, and then it gives you benefits of, you're not just taking all the water from a roof and, sending it to a pipe. A blue roof is kind of the same thing, but it doesn't have vegetation. So a lot of times it's helping to, with flow attenuation. So the blue roof can sort of collects the water and then holds it for a period of time, and then you can use it for passive irrigation or other uses, but what's that? Ground level vegetation. So this is the one where, it may just seem like it's, sort of the landscaping, it's just kind of the nice aesthetic piece of it, but these serve a really important purpose when you do have water coming down from buildings or sheet flowing across sites. The one on the right side, the plaza area, that's showing a combination of permeable pavement and vegetation in there. And, so areas like that, that can be gathering spaces and community spaces, but also providing a stormwater management approach. Again, these are just other examples of, these are all photos that I've taken. So, you know, in Washington DC and Oregon, they used, you know, these are areas that get a lot more rainwater than we do. So they have the ability to use pass-through structures that are not volume-based. They're just, you know, putting water through a vegetated area, getting the infiltration that you can, and then it's coming out the other end. But you're still getting the benefits of using that water for passive irrigation, and you're treating it. And I think, Jesse, the Green Continuum has something similar, or
Yeah, the green continuum essentially is just identifying opportunities where you can integrate, you know, regular old landscaping in lieu of hardscape or impervious areas is function. It has a high level function, so it's probably more related to the continuum of the lower right, where just planting something as opposed to paving it provides benefit. And then the way the green continuum set up is level of green LOG 1 and 5, where LOG 1 is just put in like plant a tree or plant some plants or even just mulch instead of hardscape. That's the level of green 1, whereas LOG 5 is quite literally the MS4 compliance. So any of those kind of fit into something.
and then subsurface treatment, so that's another one. These are examples of, you know, tree wells, tree planters, things that allow for water to still infiltrate. A lot of times these can be combined with permeable pavers. I know there's issues with putting trees in a bunch of pavement like this, without, you know, making sure that they have adequate root space and adequate water and things like that. But we can do it.
Go back real quick. The upper right image, I think, is something that people ought to just be aware of in urban conditions. Is, to me, that's illustrating, it's starting to get there, it's probably still not enough, but soil volume is huge for urban trees. So when you're thinking about even the image in the middle on the top there, where the tree is coming out of the cutout paver, that actually might be designed so that there's a ton of soil volume available to the tree. But the old school, you know, little 4x4 tree grates that would just, you know, it was basically a coffin for a tree. And so it's why you never see urban trees get very big, because they don't have a lot of that. So it's beyond just subsurface treatment of water. It's also about that whole biotic system.
Playground, cul-de-sac.
Yep.
And, so now we've got the water that goes to the poured in place rubber sheeting to the solar cell to irrigate it or supplement the irrigation. But it wasn't cheap.
No.
But,
But neither is replacing trees
right,
every
and
3
neither
years or whatever.
is paying for shade structure,
Yeah.
so we weighed it and we decided we're gonna go with the tree, because it's just a little bit more.
And that's where, you know, the planning component, the maintenance considerations, all of those things come into play. When you're thinking about that, the civil cell is a really unique tool. I haven't been able to use it on a project recently, but you know, you're essentially creating that space, like Jesse's talking about, below with a structural element. And then a lot of times you're filling that space with either aggregate or soil or, you know, whatever is down there. And so you can use it for vegetation like trees to make sure you get the adequate soil volume down there. You can also use silva cells for purely water management. So you could essentially treat it like a below grade rock vault in a sense, you know, where you're using the pore space within the rock to store and treat water. So there's a lot of uses to it, but it is not cheap. So yeah, go ahead.
Can you say it a little louder?
Sorry, did they use soil cells for the season tree ball?
Yes.
The large ones?
So the question was if these civil cells or soil cells were used for the 16th Street Mall, and it sounds like
Yeah,
They were.
that's a lot of what they're doing with the 16th Street Mall is providing that root space for the trees. And that's kind of one of the purposes of the actual improvements down there. So it's one of the big reasons why they're doing that work. So that those trees can now get much bigger than those honey locusts that have been there for 40 years. Those trees never got any bigger when they planted them, so.
Subsurface treatment. So again, this can be the tree wells, but then there's also French drains, trench grates, things like that, that, you know, you can use to help get out the floatables. So these are really small grates that you often see like in Union. I think these are actually from Union Station downtown. But, you know, they don't capture a lot of water, but you're also removing the floatables, you know, cigarette butts, trash, things like that, before it gets into whatever this is connected to. So, you know, it's a small piece, but like we talked about last time, if you add up all of those things together, the sum of parts, you often get a better overall system. And then the end of pipe, yeah, right about.
You've gone through a lot of creating structure treatment.
Yeah.
A lot of detail. My question is, you know, we're talking about planning. Why is it important to go to this level of consideration at a planning phase of a project?
Yeah, so why is it important to go through this at the planning phase? It's extremely important because a lot of times, you know, especially back the traditional design approach, the stormwater was sort of considered one of the last things. It was like vegetation for a long time was we're gonna build whatever we want to build and we'll just manage the stormwater later and we'll put it in a pipe. Kind of like, you know, vegetation was thought for a long time. We'll just throw some plants at it. It'll be fine, you know, which we know is not the case. And so the benefit of going through all this and thinking through all this in the planning phase is you're actually then using that stormwater as an amenity and you're planning for how water is going to move throughout your site with your infrastructure. And so it helps from that perspective of integrating it more cohesively within your design. And then, you know, Brent can talk about the planning phase from sort of a development scale with it. But in my opinion, it just helps you come up with, I think, more unique designs. I mean, it makes you think sort of outside the box of how you can use spaces as multifunctional areas.
In terms of just space allocation, if you're just thinking about a space allocation algorithm, you have to be planning to do some kind of runoff reduction, green infrastructure strategy. You have to be planning for that ahead of time so that you can reduce the amount of space that you're going to dedicate to the bathtub. You know,
Yeah.
or hopefully eliminate the bathtub, right? And so if you're interested in those stacked benefits of what all of these strategies that Ryan's got on the wall can do in terms of shade, temperature mitigation, just your environment and enjoyment, all of those things, you have to be thinking ahead because otherwise you're then just trying to jam in two systems. You're trying to jam in the system that manages all of your detention or water quality and all of those other components. Whereas if you can overlay them, you're actually saving space. And let's say in the case of a developer, you know, developers love to have more developable area. Well, strategies like this can actually give you more developable area as opposed to, say, an elevated tree lawn or an elevated parking lot island that you're just irrigating, but it doesn't do anything for you. Simply inverting that cross section now gives you detention, water quality, and the landscape that is being passively irrigated by natural water as opposed to the opposite, you know, so it's really a space allocation exercise in a lot of ways.
And I just want to build on what Jess and Ryan said. And you think, I mean, we're looking at some of these creative structure. These are, you know, probably looking at that T5 to T6, right? In those urban core, you're trying to, then in the plat process of determining what is private versus public occurs at the planning phase. Architectural standards are being decided at a planning phase. Aesthetic treatments are being decided at a planning phase. And so if you're trying to work with, if you're on the public side, working with a development, the decisions are being made is what is private part of the building envelope versus what is right of way, sidewalk and street. Guess what? These decisions impact where that line goes. If you're going to incorporate a blue roof, guess what? That decision needs to be made at planning because that impacts structural competence of that building. How you're doing the strategy to what you're saying, Jess, are you going to be treating at a building envelope scale? Are you going to be treating at an neighborhood scale with some of it going into right of way? Or are you treating it before it goes into a stream? All of those decisions are occurring and being made and pretty much done, set in stone at the planning phase. So that's very important to draw these conversations out. We're showing a lot of detail. Unfortunately, the more dense you get, the more detailed you need to be earlier on because the decisions are critical to space allocation and achieving this strategy. Just wanted to draw that out for the audience.
It's often really difficult to back into this if you're in a retrofit condition. Which is a lot of times where we're, the more urban we're working, we're often doing infill or retrofits. Much more difficult to back into.
Yeah, and that's where, a lot of the subsurface and even ground level vegetation treatments, they're small. I keep coming back to this summation of parts, to where in a retrofit or an infill, where you don't have the space, to put in massive, swaths of vegetation. Oftentimes you're looking at treatments like this just to try to get in as much as you can, and it's all beneficial. And then the last one here with the riparian treatment, this is what we talked about last time, where if you're, just putting everything into a pipe and taking it to your downstream stream corridor. This is a picture of the 33rd Outfall project that Jesse and I did, where instead of having something like this, that you can have, all different types of vegetation, it stabilizes the stream bank and all these things. If you're purely doing end of pipe treatment, this now becomes a pond or a treatment facility or something like that. And so by effectively managing the stormwater throughout the development or throughout the site, you can then better integrate the vegetation and more stability that way within your stream corridor. And then it helps with all the things Troy talks about with, sediment management, the downstream impacts of water getting into the river and things like that. So all the geomorphic principles.
I have a question.
Yeah.
When you're talking about generating these green, especially like this riparian area with those beautiful vegetation, I wonder who takes care of that? And then do you have those maintenance because as part of your planning, should they be involved in those conversations early on too? If somebody's gonna have to go out and actually pull the weeds and trim the trees.
You like the blind side.
Yeah.
We don't tell them, we just throw it in there.
Yeah, I'm sure they love that.
Yeah. No, and that's where, the maintenance is a key part of this, and then we've been trying to, we as in all of us in the industry, we've been trying to get those maintenance folks into the conversation and into the design much sooner than they have been. Again, I think for a long time it was, we're just gonna design it the way we want it, and then they'll figure out how to maintain it, but, either that often leads to, either zero maintenance, because they don't know how to do it, or over maintenance. So areas where you have native grasses that want to be a little bit taller, they don't know how to maintain it and they just mow it, which then creates a whole host of other issues from a vegetation standpoint. So yeah, we do try to get maintenance folks into the conversation much sooner, especially when we start looking at green infrastructure components that are maybe a little bit more unique, require a little bit different maintenance practices, things like that.
It's also a really good time to help establish a level of expectation. Right, when you're involving everybody in the beginning, you can start to see what everybody's, what is their threshold, number one? When we had Steve involved, with this kind of stuff, he's like, this is how I'm gonna do this. And if you can't design it to be maintained like that, it's not gonna get maintained.
Right.
Right, and so if they can't maintain it to the level that you expect it to be, everybody's gonna get egg on their face. So that is, I think, just a really important piece to be able to have that common understanding of the level of expectation. And then if you're designing to and constructing to meet that, you're gonna have a better chance of success.
And I think it's really important to note too, that there has to be compromises on both sides of it. So a lot of times we'll get pushback on designs because they want to maintain everything with a back truck. Back trucks are massive. And, if they're driving on concrete or trying to get to four bays or things like that, you're essentially putting in a road, a 12-foot, 14-foot wide road to a maintenance facility that may only need to be maintained once a year.
And you gotta get it within 12
And you
feet.
gotta get it within 12 feet because that's how long the hose is, I guess. So, there has to be some compromise, and so that's where, those that work in local agencies, that's where, you can really benefit the whole industry is working with your maintenance staff to talk about how to compromise in those situations.
And I also say that the trucks are high maintenance themselves.
Back trucks are high maintenance themselves. Yeah, they're very expensive. For a while, I know the flood district was trying to figure out for permeable pavers, where to even get a regenerative air back truck, which means it's basically forcing air down, but then it's also sucking it back up. That type of truck is even more expensive, and there's not many municipalities that even have one. So, if you're gonna put permeable pavement in and they don't have the equipment to maintain it, there has to be some conversation.
There's a good comment online just discussing the water quality in downtown areas and how that relates to tree health. So things to consider when planning.
That first flush.
Yeah,
Water.
yeah, the first flush through a system is always the dirtiest, because it's always gonna have the most sediment, the most pollutants, things like that. So that's what four bays do in larger facilities, but when you're looking at these street side planners and smaller facilities, we have to come up with more unique ways of managing that first flush. So this is, I only have a couple slides left because I think I'm probably over time. This is something that I thought was kind of cool. So I overlaid it. This is from an example from New York. This is out of a book that came out several years ago from the National Association of Transportation Officials, where they showed a retrofit example in the city of New York. So this is the existing conditions. They have some trees, but like Jesse said, they're pretty much just the 4x4 cell. There's not a lot of vegetation. It's a lot of impervious area. Then they have this interim redesign. So you can see now they've transitioned, instead of a full 2-3 lane roadway, they've now integrated a bike lane. So that's where you're getting your recreational components, your community amenities. They're starting to put more planters out there for vegetation, things like that. And real quick, just look at, the people in the space here. So that's existing. This is the interim. And then this is the final, capital reconstruction. To where instead of a protected bike lane with striping and flexible bollards, now it's completely separated. Now they've elevated the bike lane with curb. They've got tree lawns separating it. Look how much, I'm assuming those are the same trees, and look how much healthier they are going through, getting to this point. Look, and, and there's much more community engagement, things like that. And so this is an example of, this is just a retrofit of essentially a median on a roadway. But how much more beneficial and how much better this condition is versus what was existing. This is the, I've mentioned this last time, this is the Portland Office Park project. I don't know if we have time to watch the YouTube video.
Sure,
Sure, okay.
as I've practiced
Yeah.
this.
Okay. I
Keep talking. It's gonna take a while though, so start talking.
So just to preface the video we're
End
watching,
slideshow.
I actually went on a road trip. I went to Oregon. That's what I do on vacations. Instead of going to see like,
Stop sharing.
monuments, I go to see water quality facilities. But it's a great project, and the video will explain essentially everything that we're talking about and how they integrate functionality, community, all of those things into the one site with stormwater management and water quality.
Fudge. Okay, hang on. Don't understand. Wait, don't go. Laura. I did it all the right way.
You did do it all the right way.
Okay, share.
While we're waiting, there's a lot of blueberries back there.
With Sam.
Fuck. It's not sharing on the screen. Okay, it's this. Boom,
Okay.
share, sound. Please tell me it's on there.
It's on there.
It's not.
It
It's
is.
on there.
Sorry.
It's on, okay,
Oh, here we go.
okay. I shared with
Dean
sound.
came up with the idea for
damn
using
it.
umbrellas as
It is unmuted. Fudge. Okay, you won't know how many times I freaking practiced this.
They can hear it online.
They can hear it online. Okay, well, you guys in here are just gonna have to suck it up, Buttercup. Sorry,
Or we can.
we'll figure it out. We'll play it later. Are they hearing you?
Dean came up with the idea
They're hearing it
for
online.
using umbrellas as the concept for this open space in the fountain.
I
We
know.
were looking for ways to tell the whole story from raindrop to the drop that goes into the ground for saturation.
He knew he would need help from civil engineer in terms of how do we make this function and how do we drive this with stormwater. What inspired the umbrellas, I think, was really just a Portland take on our overall climate.
The idea of the water coming up out of the umbrella, flowing through the plaza itself before it goes away, was all part of the story that we were trying to develop.
Dean introduced us to the artist. He was aware of his work and familiar with some of his pieces.
I stole my wife's umbrella, and we took it and we had it digitally computerized, so we placed dots all over it and created a 3D map of the umbrella itself. And that was the beginning of my relationship with Michael Maiden.
The umbrellas are very lifelike, and he'd never crafted anything like that before. We often can come up with creative and innovative things that might look good on paper, but because of budget constraints, they don't actually make it into the final project. And this project was unique because the owner was determined and committed to make sure that this became part of the project, and it now serves as a focal point. This is probably my favorite part, how the fountain actually works. Rainwater that hits the roof goes through a siphonic roof drain system. Through these special drains, water comes down through the building, is collected in a single pipe, is piped out through the basement, underground on the ground level, and then driven through piezometric head up through the fountain. And then from the fountain, water spills into a vegetated swale. Here we get water quality treatment. It flows along this swale into a lower drain. When water reaches the drain, if it hasn't yet infiltrated, it has yet a second opportunity to infiltrate in a below-ground rock pit before it overflows into the combined sewer. Probably the most interesting thing about this fountain is how many different functions it serves, whether people realize it or not. It was an opportunity to realign an intersection. That's a transportation improvement for the community and the employees. It's a stormwater feature that diverts thousands of gallons of stormwater every year from an overcapacity combined sewer that's aged here in City of Portland. It provides an amenity for the employees, a healthy place for people to go outside and get some fresh air.
While Providence paid for the plaza as part of its project, its intent was always that it's for the entire metropolitan area of Northeast Hollywood. Most people think that a raindrop falling is its most purest form of water, and in most cases that's true, but in an urban environment, it's where that raindrop falls.
Stormwater sustainability is something we pride ourselves on here at KPFF, coming up with unique solutions to unique problems in unique situations.
Okay, stop sharing.
Mary applause.
No, don't, no. God, it's excruciating. Oh, no, wait. Ah. Sorry, everybody.
Some eye candy for that.
So, yeah. Back.
We're back.
So
probably the biggest thing that I take out of that, one, I just really like the way that they pulled this together, but it's what you said at the end of how many different purposes this project serves, not just for the building and the employees here, but for the community at large. And I think those are the types of things that, you know, we're really trying to stress with Stream Academy and moving forward is just how much we can integrate into a site if we just go through that planning process, get everybody involved early and talk through these things.
For you, I think you're exactly. Yeah. I just want to check in, is everyone good to keep going for a little bit, or do you need a bathroom break? How about a Roman vote? Break, okay. So let's take a 10-minute break, and then we'll come back and get onto the high functioning ones. 10 minutes, be back at 9.
I don't think I'm gonna take 40 minutes.
Well, I won't take 45.
You have 15.
Oh, 15, well, then I won't. Wait, it says 9:15.
And 9:50. For your.
That was 9:15 to 9:30. 15 minutes. Rob.
I think my plan is gonna take 40.
No, 9:15 to 9:30. But I'm glad because I.
It's 15 minutes.
It says 9:05 to 9:30.
Yeah, seems like we're. It's a little bit.
Make sure.
Oh, now we're green.
Okay. Are we all? Except you have to click into the PowerPoint.
Yeah.
There it goes. Okay. Just so you know, I'm still sweaty from that YouTube adventure. We tried so many different ways yesterday I practiced, I had a 8-point list of things I had to do to get that thing to go, all for naught, but oh well. All right, well, we're gonna switch gears a little bit and go from highly urbanized areas, and maybe next time we could switch maybe we should switch our presentations, but anywho, we're gonna go back to nature, more nature instead of distributed nature. To talk about a little bit about these higher functioning, lower maintenance systems that hopefully you've all heard about through various symposia and whatnot from the district. Who here has heard of high functioning, lower maintenance streams or systems? Oh, this is very gratifying. Thank you. All right. And online, I'm sure there was a high percentage as well. So thank you for that. So this is an example of not high functioning, lower maintenance. Again, we've seen lots of hearkening back to the old days of the way we did things. Is this, when you're thinking of the fail, what is this? The two versions of types of fails, what type is this? Fail safe. But you can already see what happens when it does fail. Here's another one. It is, whoops, when these things fail, it is catastrophic. There is no, remember, the safe fail means it moves to another state, but it still functions. Is this still functioning in this new state? Not at all. So, yeah, it works really well, but look at the context of this. Let's just say, in our world, if we're looking at it now, the area on the left that doesn't have the fence line, what if we were able to have that space? Does it make sense to put a system like this here? We don't know for sure, but I would sure want to know, can we do something different with and add more space so we can see if we can get a safe fail in here instead of this fail safe? Again, another example, you know, some of these are from Denver. Aurora has a fair share of these. Westminster has a, yeah. Westminster has a fair share of this type of system. And, you know, obviously there are reasons. I'm not trying to throw shade back for folks back in the day. People, we all do things for reasons. In 15 years, you're gonna be looking at what we did and say, yeah, it's so crazy. Because it'll be better, right? We'll learn, we learn. So there's that reinforcement, fail safe. There's only one functional state. It can take a lot of stress though. That little ball can go way up the sides and it'll fall back into its equilibrium state at the bottom. Whereas the safe fail on the right side, the little ball, it doesn't take too much. It can take some level of stress, but then it tips over into the new state. And that can either be a wetland into an upland into a wetland, you know, just a different kind of wetland. So there are lots of opportunities to move to different steady states in a natural system. And that's where we get our adaptability. The resiliency comes from this ability to change states, but still be functional. But even one of these systems at some point, too much stress, it's just, it will fail. It will fail. Wow, we've seen that. I love all the fails. More fails. This is getting at the point of the red line is the cost over time, over the life cycle of this thing. The initial cost, very high. The trough in the middle maybe is the maintenance costs over time. You don't do a ton on these things. Maybe get a little skid steer to get the sediment out, but you're not really out there year after year doing something. But when it fails, you start over and you have to rebuild the whole thing. Now, in reality, is this second curve the same height as the first one? Or does it cost more to replace? It's 30 years later. Is it gonna cost the same amount to put it back? No. No. Inflation is gonna boop, put it way up there. Do you think the municipality has been saving up their money? Right? Yeah, that's the other thing, right? It's you get these big capital costs. Instead, where it makes sense, we can use more, and we have the room, we can use more vegetated solutions. That, yeah, this might need to be mowed every year, or might need some trash pickup and whatnot, but it can handle the flows, and if it does deform a little bit, it's not gonna take a huge capital investment to put it back. A great example of this is Westerly Creek. Who flew in and out of Stapleton Airport in their lives? Okay, we got a few old timers. Yes, so Westerly Creek, they took out to me, this is just, holy, isn't that great? Talk about a redevelopment project. So they took out those runways and they made Stapleton, or I don't know what it's called, Central Park now. And they created Westerly Creek. And they had the space. Look at the planning that they did. Look at all the space they gave that creek. And this eventually dumps into or confluences with Sand Creek.
This is 100% developer led, that project.
Yeah. I was on that. I worked on some of this at the time. And the developer was very forward thinking. Very forward thinking, had a lot of good people on the team working on this development. Yeah.
Good design.
It was a good design team. So here's Westerly Creek during the 2013 flood. You see that pedestrian bridge? This is smack in the middle of the space. Huge flood. Day later, it's drained. I mean, it's already back to, there's some stuff on the bridge, the Ped Bridge. Maybe you want to watch your step, but it's back in business. 8 months later, you would never know. I don't think they did anything other than pick up some trash on the trail. There was virtually no post-flood maintenance needed because of the space. What does the space do to the flows, the velocities? So down, makes it go down, more space. Oh, look at this, more space.
That's almost like you thought.
It's like I planned it. More space gives you lower velocities. And what does that mean? That means you can use those vegetated solutions. Now, up here, it says concrete, but if you had this system, say this is your, on the left, for those of you online, concrete, it says concrete, the blue. If you're coming into a system like this, pre-project, is this a good look for using vegetation, the blue? Probably not. Your velocities, you're asking way too much of that vegetation. So if you were here and you're like, well, we have space, that's where you would try to transition it down to the more naturalized cross section. So you could take advantage of the space and the lower velocities and get that vegetation. Does it mean a lot of earthwork? Potentially, although what do most of our projects do? A lot of them raise the invert back up. So we fill the channel to have it access the floodplain again, and we get that space that way. Sometimes we do actually end up laying the banks back, and that's where you can get a fair amount of earthwork going. But we try to do a combo, right? But wherever we can, we try to take advantage of that space. Any thoughts on this? Kind of makes sense, right? Says the non-engineer.
Makes a lot of sense.
Okay.
Does anybody know offhand what the velocity ranges are for erosion? The district used to have a table. I don't know if it's in the manual anymore.
What type of soils?
CFS.
What's that?
7 CFS.
Yep, 7 CFS for what type of
What type
soil?
of soil? Sandy.
Right, cohesive, non-sandy soils. That was kind of the sort of guiding, people online can't see my quotes, guiding value was if you could stay below 7 feet per second, generally, avoid a lot of erosion. What about sandy soils?
It's 5.
5, yep. Now, I think those were assuming non-vegetated, that was just purely the soil. But just you know, relative to what's on the screen now, just to Mary's point, you start getting into the 8, 10, 12, 14 feet per second, and you're gonna have some major issues, even with vegetation.
Did you say there was some sort of matrix on this somewhere?
Well, the flood district in their criteria manual, they used to have a table that showed it. I don't know if they do or if that's been changed since then, but it should be listed in the flood district criteria manual. What's that? Table 8-3. There you go. Wow. Thanks, Bennett.
You ever been in there, Bennett?
No idea.
Well, it's a good thing, though. Remember, Ryan's caution about don't just go to the solutions in the tables and the specs and have the conversation, right? Please don't base your decisions on what you're gonna do on the table. Hopefully there's some thought that goes into it and have some discussions with your multidisciplinary team on what would be an appropriate solution, right? What's reasonable to ask of your site in its given context. So I'm just gonna flip through these real quick. This is a poor little drainage in Highlands Ranch. Before development, it was just an upland vegetated swale, no big deal. Remember, Highlands Ranch said, we're gonna give the creeks lots of room so that we don't have to get in there and mess with them. But they were thinking about what flows? 100-year events. Plenty of room for 100-year events in here. But what's the base flow? What's the change in the base flow happen? What's the point about the base flow? What does it do? If you increase it with impervious surface, every day, work. The little chip, every day, 24/7, this is what you get. To me, this is more damaging than a 100-year flood, really. But anywho, so they addressed it with bioengineering. Those are hay bales, erosion control blanket. This is just like someone trying something. Jim Wolleman, bless his heart, he's willing to do anything. So they went out there. Did you put some of these hay bales in? No. They went out and they used hay bales. Yeah, that's Jeff Wolleman down there in the front. Anyone who knows Jeff, you can give him a hard time about this. So this is post-construction. They put some willow stakes, all kinds of just soft things in there to fill up the thing. They did have a flow pretty quickly. This is stuff they were doing in 96, people. And now we feel really progressive because we're starting to do more of this everywhere. But everything new is old, right? This was all happening in the past. Anyway, they did have some blowouts. But luckily they had the kids go back out and fix it.
Nice.
They fixed it. It was easy. It took a day of some volunteer labor to put it back together. After a year or so, it starts looking pretty good. And then this is X number of years later. Now, I will say, this looks great, but what do you think about that vegetation?
Flow capacity reduction.
Yeah, flow capacity reduction. It might be time to do a little vegetation maintenance. Is it gonna be as much as replacing a blown out trickle channel? No. You're good. You're good. 1 year. Okay. They need to reset. Jesse talked the climax. We need to have that disturbance to reset that vegetation. That's the maintenance piece that comes in with vegetation. Constantly have to reset it. They stopped mowing along Cherry Creek, the walled portions, because, hey, let's try to reduce maintenance. What happened? Ding. It's covered with trees now. So we didn't anticipate what the result would be. So here's, I think, my final example. Is it important to protect these homes? Is it important to have some fail-safe aspect to this channel? You bet. You bet. So we have granite boulder walls, but look at the bottom. Those are little bio bricks that were built. Those aren't pavers. Those are bio bricks that allowed vegetation to be used in the bottom. It's awesome. I mean, what a great combination. This versus this, same thing happening. Here's the site recently, still functioning. Is it time to do a little maintenance? Yeah, because these are not no maintenance systems. They must be maintained. Yeah, Andy. This is on Kinney's Run in Kinney's with or without an apostrophe, depends on what map you look at. Kenny's Run in Golden. Pretty cool. Again, we gotta reset it, and that's the maintenance. So hopefully, we'll get it back to that. The costs, maintenance, the little green blips. We're just gonna rip through these. Again, just some examples of some designs that we put a lot of thought into. I'm not gonna, we'll go into, you guys will get the details. But the point is, a lot of time needs to be spent on talking about these systems and how they can be repaired. The cross sections are agonized over as far as setting the elevations of the overbanks. How wide is the low flow channel? How deep is the low flow? We want to move sediment, but not too much. What can we ask of the vegetation, et cetera? So a lot of time and effort goes into these. A lot of time and effort goes into the plantings. What goes where? Who do we ask? Who goes where? Very detailed plantings, all based on the elevation above the water table, which is down that bottom line where the pots and things are located. So these are some of the aspects we're looking at: the ordinary high water mark of base flow, bank full, lots of different geometries. I'm going to skip all this. This is just a point here on this. Is there vegetation? You need to think about it. Where is it happy? What can it put up with? Do you have a lot of diversity in your seed mix, or just go for a couple of heavy hitters? Probably good to stock the shelf with all of the above. Get some guys that can hang on through most things, and a bunch of specialists that'll help fill in the gaps.
We had a quick question, Mary, on if the vegetation in the biobricks can withstand velocities over 7 feet per second.
Well, I'd say, yeah, because that little narrow thing gets blasted. So they were lucky. I mean, that's not to say that you wouldn't have it perhaps in one setting before it got established. It might have blown out a little bit here and there. But in this case, it was able to hang in there. But that Kenny's Run is not a small drainage way. This is up downstream, I think, of Fossil Trace Golf Course. So it's a ripper when it goes. Yeah, so it was able to handle it. Anyway, lessons learned, just talk, get your team to think things through and be very deliberate about what you're doing and asking of your natural systems. They can't do it all, but they can do a lot if you understand what they're capable of. So we can go from this to this. Well, which would you, I mean, yeah, why not? Let's do it. And I think that's my last slide. And we already had our break. Are we gonna skip the break?
We're gonna, yeah.
We're plowing on. Brent,
I do want to check in before Brent, that just what questions you all might have for Mary.
There's a hand raised in Laura, I don't know if you saw that.
Yeah, I was gonna ask Jose if you wanted to type it in.
Yeah.
bless you.
If you have a question online, just type it in.
Yeah,
So
Grab it.
there was a question about, you know, what do you use to fill the channel? So when you have erosion like this, what do you come back and you fill the channel with? A lot of it is dependent on what those existing conditions are. So I added it to the chat, but for example, if you're dealing with a very sandy system, like Timbers Creek, which is out in Parker, it's kind of a headwater condition. It's extremely sandy. You can't just put riprap and rock and expect it to stabilize, because that rock will just move with the sand, you know, when the sand gets pulled out. You know, that was another example where drop structures, concrete cutoff walls were used to try to prevent erosion. And because of the sandy system, it just went around the cutoff walls. So now you've just got a concrete wall sticking up in the air. So a lot of times, depending on the existing soil conditions, that's going to determine what you can actually fill the channel with. And Troy can give a lot more information on sediment transport and those specifics.
Is that it? Any questions? All right, we can talk about planning. So we're on to shaping tomorrow. So I'm gonna go through the role of planning, the planning process in a nutshell, And then also, just some takeaways from the planning process. I really like this one, in Seinfeld when, Jerry was mentoring somebody to be an architect and actually wanted to be city planner. So, it's one of my favorites. So as a planner, or in planning, what is the goal of planning? And really it's, strategically guiding, the development of our urban areas, really. Doesn't have to necessarily just be urban areas, but just our land areas in general. But, design, create policy, problem solve, advocate, for all of our needs, and then, infrastructure. So as planners, we guide the development process, enforce the policy that's kind of created, through the planning that we do, our comprehensive plans, our neighborhood plans, our site plans, what else? Standards and specifications, all of that. We advocate and we try to predict the future. So when we're, coming up with our comprehensive plans, we're really trying to figure out the next 50 years is really the goal of those. And so what it all really comes down to is we're just trying to allocate the space, whether that space is for, development, if that space is for parks and open space, if that space is for what we're talking about today, which is, stream management. So, I like to go to this project. This is First Creek Park in, Green Valley Ranch. And, the red lines are the, property lines. The blue line is the stream, that's First Creek. And then, we've got our floodplain. The question is did we allocate enough space? And I think the answer to that is, it's all about context. We don't know. We do know, but really that's where the planning kind of comes in. So I'm gonna go through, the planning process here, but it really all starts off with the comprehensive plan. And how municipalities do it, every one of them is different. I'll keep saying that over and over again. This is just a really big generalization of the planning process, but they set, your visioning and goal setting through, maybe it's your key leaders of your municipality or jurisdiction, defining your long-term goals. Then you would go out and do data collection. What is our population going to be looking like in the future? What are our land use needs? And then, any environmental data. And those are just three of the options of what. So then you go out and start doing public engagement. What do the people of your jurisdiction want? What do they want in the future? You gather that input and then you start drafting that plan. It would include zoning and infrastructure strategies. It also include population growth projections, and again, it runs the gamut of everything that a city can offer as far as the needs for the people. So then you would then, create that plan, and then you would start with your implementation and policy development. So how do we make this plan come to fruition? And how do we enforce those regulations? So if you think of a comprehensive plan as more of a regional scale, you would also then go to a neighborhood scale. So City and County of Denver does their comprehensive plan for the whole city, and then they have neighborhood plans for each of their neighborhoods, which then kind of guides the site development. And so, let's see here. After that comprehensive plan is approved, then you would then start to develop your standards and specifications. So how we are going to implement that is through, it's usually done on the site plan level. And then, your development goes through that development process through the standard specifications that are developed through the various departments of the city. So how this kind of looks graphically, I'm going to kind of show how the process works so that we can kind of get a visualization. So you would do your data collection and your visioning goals. You would have your public engagements. You would create a draft plan. Implementation and policy, your actual policy. And now we've got a comp plan. So then we are now looking at how it all puts together from the site. When the developer comes in, they're gonna start looking at what was developed in the comp plan. What am I allowed to do? And then looking at the market analysis. They're gonna come in and do a density study if they're doing a large scale development for, say, a neighborhood of homes. And then we've developed a concept plan. We're gonna go into the city and do a pre-app. And make sure that what we're doing is congruent with the plan and what the municipality or jurisdiction allows. Then we're gonna develop our plat and our plan. And make sure that that is all congruent with everything that's allowed. And sometimes that's kind of broken up even further into a preliminary and a preliminary plat, a preliminary plan. And then you go into your final plan and your final plat. And this is what a lot of people refer to as entitlements. What am I entitled to do for my development? Then from there, we move on to construction documents. And that's where your permitting comes in. And then we go to construction. So there's a lot of things that happen before we can go to construction. And this is in a perfect world. And again, every municipality is different on how this all works. The entitlements sometimes have to go through city council to get approved, sometimes not. Maybe that you're not going in and changing any zoning or doing any changes to what the comprehensive plan says, and so everything's administrative. But at the same time, every municipality, like I said, does it different. So, yeah.
What, last time, what would you say the time scale is?
Oh.
Not to scale.
Thank you.
What would you say the time scale is?
Well, the comp plan, a comp plan's done every 10 years, more or less. Entitlements can take, depending on how your development is looking, it could be 6 months, it could be a year. I'm working on a plan right now that's still going through entitlements that I've been working on for 8 years. So it all depends a lot on the market as well, but also just the process. It's a long process, and so it's called entitlements for a reason. This is what I'm allowed to do, but you've gone through that huge process to get there.
The other thing that's really important, especially with new developments, is during that plat process, that's when oftentimes your drainage easements, your stormwater corridors, all of those things are being determined through that planning and that plat process. And so if you haven't gone through the concept development or even thinking about, how you're going to manage your runoff from the site, what could happen is you could end up with a drainage corridor that's very confined. And then you're not left with a lot of options, when you actually get to pulling together construction documents. So, it's extremely important to keep that in mind if you're going through that plat process.
Yeah, absolutely. So going through that process, there are, certain certainties are desired from every party, right? So the municipality, this is why they're doing their comp plan. They're looking for protections for the good of the public interest. That's really what the comprehensive plan is doing. It's making sure that we're moving in the right direction. The developer, when they're doing their entitlements, they're looking for what can I do, what can I not? And then, you look at your public-private elements, just what you just said, it's stormwater considerations. Where is that happening in the process? And a lot of times that doesn't actually happen until later on. And so are we making sure that we have the right allocation? And then lastly, we're looking at standards. Architecture is one of those standards. It could be a number of different things, but just how we're putting it all together construction wise. And with the ultimate goal, everybody uses this, but it's the highest and best use of land. And this is where that context comes into play too, right? So maybe it is sometimes a trapezoidal channel is the highest and best use, but maybe it's not. maybe we can look at it a little bit more comprehensively. So developers are also looking for some flexibilities. They're looking for how their building envelopes work within their setbacks. And the municipality is looking for protections of the good of the public interest. But what happens if there's a change after we get through those entitlements? What if you get to your construction documents and figure out that you need more space because your phase 3 drainage report says you need more detention than you actually paid for? How do you justify, how do you go back and do that? A lot of times you're gonna have to go back to council and get reapproval on your plan because you need more room. So we really need to make sure that we're getting it right in some of those early stages, in that I would say even in the market analysis, in the concept plan. And so, and we'll talk about this a little bit later, but that's where your multidisciplinary team comes into play. But I think the question is, how do we prepare for a need that we don't see coming? And that's the overarching question is, are we allocating the right space for the right things? So with role planning, takeaways are planners allocate the space. All municipalities do it different. The major details seem to wait till the end of the process to get figured out a lot of times. I always go back to that phase 3 drainage report where it's saying you're gonna need more detention than you actually paid for. And how do you now fit that in? And then our comprehensive plan versus site plan. Are we really using the comp plan as intended in our site planning? So our site, like I said, our site planning is kind of where all of the work that you did prior comes to fruition. And our regional considerations accounted for in our planning. This is where we talked about last time with Platt Farm. And are we making sure that we're looking at our projects regional as well? Is there a connection that we can make that we're missing? Is there, something that we could add to our project for a value add that could create something for the greater good? And then the policy changes that are associated with that comprehensive planning, just making sure that they all follow suit. Sometimes you can go through a comprehensive plan, but then your standards and specifications don't necessarily follow suit for a year or two, because it takes a while to develop those. And I also talked about teams, so we talk about collaborations, but we can always do better. And I think knowing who to call is half that battle. Yeah.
That's right.
That was Jeff. Shoot. No, it's half the battles. Okay. Anywho, where in the development process does the stormwater management planning occur? What is everybody seeing?
Master plan.
Master planning? Do you have the right teams when that's, being developed? Is it the correct amount of space? Are we providing that space? Yeah. Kind of.
Depends on if it's the planner telling you the space or the engineer telling you the space.
What does the planner say for that space? I'm interested.
Oh, they make the fonts be small.
Yeah. Because they usually use like a formula, right? Like, oh, we have, this amount of area, we're gonna need a pond that's, based on the acreage, we're gonna need a pond that's, half that or a quarter of the size or.
I think that's what the engineer does. I don't know if the planners do.
So why do stormwater management plans come into play after design, during, like literally right before construction? Like, it's a little confusing, but. Yeah.
I don't know.
That's what we're trying.
That's what. I'm working on a project right now and it's a house in a municipality that I'm the town planner for. And they didn't have to do any entitlements. They had all their entitlements done. And they came in with their building permit. And I had to tell them last week that I need them to go back and do a phase 3 drainage report because they're adding all this impervious area. And they were flabbergasted. Where was this? Why didn't I know about any of this? They had it all laid out. They were ready to break ground tomorrow. And I said, no, I need this. Maybe you have it all right, but I need to make sure. And our engineer needs to make sure. So now they're having to go back and redo their plan. Because they didn't, first of all, they didn't know the regulations. But also they didn't plan for those unforeseen circumstances. And this is a 2-acre home in the middle of the town. And because they're agriculturally zoned, they didn't have to go through any of those processes. So the planning part of it, we all probably could have done better, but they needed to read the regulations prior to going through and having all of their construction documents ready to go, which is a lot of work.
Did they move in from another state?
No, they're from here.
Okay.
Yeah.
I think an important component to this, it's interesting that you said the planners always make ponds too small. I would argue the engineers always make they're trying to do, this is no, I'm not throwing shade. I'm not, you just have personally to him. No, typically, it seems like we're designing for efficiency. And we're typically designing for efficiency in maybe 1, maybe 2 of those elements. So when we're designing for efficiency of 1 or 2 elements, we tend to kind of block out what those other things are. And so if an engineer's job or if a planner's job is to think about that one thing, and this, of course, I'm going to go for the least impactful for the other things. So that kind of what Ryan was getting at is what we're trying to do is get everyone to sort of shift thinking and go, hang on a second, I need to think about more than just getting water from A to B, or what's the adjacent land use, or where can I stick this little pond, this cute little pond over here? You know, if we start thinking about those things, we can change that vocabulary and understanding of what the space needs to do. Then we're all making better decisions, because in those early vision or master plans, you know, those plans are setting lines. I mean, they're making lines, and if your line is set by a very efficient trapezoidal channel that doesn't have enough understanding of what else needs to fit in that space, you're kind of screwed, you know, because now you got that line, and when you go, oh, well, you gotta get trail in there,
Yeah.
we gotta get water quality in there. You know, we gotta get head wall in there, like all of a sudden, you don't have space. So that's the point.
Yeah, well, that,
Earlier you can say, this space is all reserved for all these things, the better.
and a lot of times we're planning for the bare minimum in some of those spots, I would say. Whereas we need to start thinking about the bare minimum plus a buffer or whatever that strategy is to be able to give us some wiggle room, right? We want the wiggle room for lots of things. We give ourselves that wiggle room when we're doing setbacks for building envelopes. We're not gonna be able to put a foundation within an inch of where it needs to be. That's why we give setbacks are, 25 feet from each property line. But you're not gonna build a house that's 100 feet wide. You're gonna build a house that can fit into that envelope. Maybe we need to start thinking about planning planning for our streams the same.
I think that's a really good point, and Jesse brought this up during one of the last classes, but we do a really good job at setting right way, with the understanding that a 2-lane road now may become a 4-lane road in 20 years, because of population increases, things like that. We need to do the same with our stream corridors, knowing that, okay, it maybe only needs 50 feet now, but in 20 years, 30 years, it's going to need 150 feet. To manage the additional urbanization, the additional population increases, all of those things. So I think the mindset is there for certain things, and we just need to translate it over to the stormwater management, stream corridor side of things as well.
Even things like soil type, to your point, if you're not considering soil type when you're allocating that space, you could get really messed up when you when you didn't plan for a sandy system that needs a lot of space to move around and you're locked in, you know.
As development
And
goes,
that usually doesn't get considered until later on.
right, as development is, moving forward or moving more to the east, we're getting into more of those sandy systems. And so it's something that needs to be looked at. Needs to be, allocated. Don't know if I have them all. Oh, so back to this. Did we leave enough space? It's the eternal question, and I think that we would rely on our team to make sure that we did. And I think a lot of that comes with engineering, geomorph, and then and how that works integrated with our planning. We're not gonna be able to give it, sometimes not give it all it needs, or maybe we can give it enough.
And this is where the compromises come in too. I think for a long time, there was, parks departments and other agencies or organizations that manage its corridors. They often wanted like trails completely out of the floodplain or, park benches completely out of the floodplain, things like that. Which makes it really difficult when you're in confined spaces. You wouldn't have been able to add all those trails, all those improvements, anything like that in this corridor if the blue was your floodplain and you had to keep everything outside of it. So, that's where that compromise, working with your various departments, really going through that planning process, getting everybody comfortable with the fact that you can have a sidewalk in a floodplain. You may have to come through, like Mary said, and just pick up some debris every once in a while, but ultimately it's not creating a negative impact.
I'd even go further too, with playground equipment. And even in detention facilities as well. There's, that's only used how often in a year are we using our detention facilities? Is it something that we're gonna get beneficial use, in the other times of the year? Some municipalities don't allow it. And the other thing is, a lot of municipalities require, a certain percentage of your site to be open space. The detention pond sometimes doesn't include any of that. And so how can we use that space for, the greater good and for other uses beyond stormwater? There's some real creative things that we can do with these spaces. We're doing it. Jesse's doing it. What are you doing? What questions about planning?
Just say one thing about this project. Again, I just want to recognize this is developer led. They actually set aside the space and bring that with this neighborhood in. They also, they gave the dollars for the trails and many amenities to the city and county of Denver, whole, knowing that there was a larger mission here. And this was done very early on. Land was set aside and dollars were conveyed from the development community, the city and county of Denver, so that when the city was ready to do a larger project, we had those dollars to build in. So I just wanted to recognize really the city and really this developer for being very important.
First, I want to say that's really cool part. Thanks for the moment.
Yeah.
My other question is, so kind of the point of this is we want to move some of the things we think about later in the process, early in the process, save time, money. Is there a limiting principle for that where I feel like you could do a lot of the things that you normally do with final design, final drainage report, do it so early, and then you get in and find out, oh gosh, there's something to change. You've done all the calculations that you wouldn't normally done later, and you have to go back.
Yep. I think, maybe, no, but, getting the right people in the room at that early stage of the concept design, I think is the bigger one. And I think from a municipality standpoint, requiring a little bit more documentation up front might be part of that solution, which would almost be a policy change. But then just making sure that you've got those analysis done prior to really putting in those hard lines. Is I think the biggest thing.
Yeah,
But, yeah,
and I would add that, because I agree, you're not gonna have every calculation done, in the planning phase. But that's why we're harping on this space allocation, because if you give it a much wider corridor, and then something does change during CDs or an assumption changes, even if you expand slightly, but you're still within that larger corridor, then you don't have any issues, right? Then you can just update your calculation, but it still fits within the plan. Where we get in trouble is when you squeeze that corridor down for whatever reason, and then you find out that something has changed. Now you've got to go back out further than what the corridor allows for. That's where, a lot of the rework, a lot of the, issues with going back to the planning phase, redoing easement lines, that's where it gets really tough. People really don't like doing that. So that's the whole space allocation mindset, is just give it the extra room. And then as you go through design, then you can start, manipulating that space however you need to.
If I could just build on that, Ryan, I think it's also context. So
Yep.
if you go back to the transect, if you're in that T5 to T6, space allocation at those are very critical. And I would say, don't just give it space for the sake of space, but space, I think, right, you put this in space, it's nothing. And so when you're having a conversation development in the T5 to T6, I would say more detail is important.
Yep.
Because those changes are painful. But when you're in that T3 to T4, we're not talking channel design, we're talking corridor design, which are two different things. And we'll talk through that distinction later. The corridor for a T5 to T6 is the same as the design space. But when you're talking about a T2 to T4, the corridor is wider than your channel. And so the key is to get your corridor analysis finalized, but you don't need to finalize your channel. I don't know if that distinction helps. So as you get closer to your T6, more design is needed earlier because space is more premium. If you're talking a building envelope to a sidewalk interface, that's how tight things are. Those details matter if it's neutral to urban. But when you're talking like Great Valley Ranch here, the corridor is all you're needing to final design on. You're not final designing a channel in the plan. And I think the trigger, if you want to tie it to, whenever you're doing line, whether it's on a T6 or a T3, that's when you need to have a space conversation. If your design is going to change your space allocation, you just need to leave the design. I don't know if that's all, just wanted to capture that discussion.
Val, can you talk about how that worked with the Timbers project with, leaving the corridors kind of open a little bit more? Was that was more work on the front side? But how did that work policy wise with going through the city?
Yeah, I would say the Timbers Creek, Independence Ranch, the Marcy Gulch example, again, those space was set aside during lotting. So when they went through and did their density studies, the bubble diagram, the pro forma studies, that space was allocated at that time. The space was finalized when lotting was done. The design of the channels, or in that case, maybe back there, came later. But the space was set aside during the lotting, and from a policy standpoint, I would say, and I had this conversation earlier with someone here, that it wasn't so much the regulation that drove setting aside that space. It was really the goal of really the Independence Ranch Metro District. We want to create a community of open space. I mean, they came in with that. They weren't told that they needed to do that. And I'd say that that's true for also the Timbers project. They really wanted to leverage the beauty of the topography and build that into their development community. And they moved in order to leverage that, they had to set aside some space. But the key thing there for both of those two projects, because we had the space, the retrofits were possible. We weren't fighting against space to do what we needed to do. But those were done during lotting, and the policy and the regulations didn't drive that in that case, because the goals of the developer was really to leverage the beauty of the land and build it into that neighborhood, which isn't always the case. And when it isn't, then we need to have a different approach on how to engage those types of projects.
Right. So it in those projects, it would take an advocate from the planning side, from the engineering side, landscape architects. Any of those to advocate for that space to be able to have it for later if needed.
And I would say, I had this conversation earlier, I'll just throw it in, we'll talk about the specific on projects. I think a lot of times we approach a project from a community standpoint, obviously public works, because I'm on that side too, is we dock with the project going, here's what we need. And that always sets up the project, the conversation to be challenging right from the get-go. And I think instead of doing that, we approach the project with, what are you needing out of the project development team? Here's what we need, we're struggling with it, how can we solve each other's problem together? So I think the advocacy piece is advocacy for the project as a whole, including the development in that bubble. I don't know if that hits what we're trying to touch on, right?
Yep, that's great. It's kind of moving forward. I think we're talking about June.
It's actually a great segue. We're talking about stream management corridors. And how do you,
Perfect.
how do you know what kind of corridor you need? That stays out.
So, this is normally where Troy would present. Because, you know, this is related to the geomorphic principles he's talked about and how you're actually allocating the space for a stream corridor. But I think we can go through this and so Bao and others, you know, chime in as I'm going. But what's the best tool to manage the stream corridors? Give them space, right? Shouldn't be new. We've been talking about this the last 3 classes. It's how much space is required and how you determine how much, you know, what that space is. So again, lanes balance, you're probably gonna see this every single class, just because it's that fundamental idea of how, you know, you turn and twist these knobs, like Jesse said, and how it impacts the corridor itself. So this is a quote: without an understanding of fluvial geomorphology and the impacts of catchment developments, it is likely that totally inappropriate enhancements will be proposed that destroy rivers and natural processes. You know, I think that's really important, and that relates back to the photos that Mary was showing, was, you know, when we focus so much on flood control and confining a stream to what was needed specifically for that 100-year flow rate, that's where, you know, we've lost sight of those geomorphic principles. We've lost sight of the development itself. And then, you know, when you put in that concrete channel, yes, it may function for 5, 10, 15 years, whatever it is, but then you have that catastrophic failure and now you're essentially starting over. And so that's why it's so important to really understand these principles. You don't have to be an expert in sediment transport or anything like that, but just knowing how things adjust based off the input parameters goes a long way. So rivers reshape land and bad planning gets washed away. I don't know if Troy came up with that or Bao did, but that is interesting.
And here's why, because Troy, who's amazing, really loved this quote.
Yeah.
And I was like, Troy, I don't know what that quote means. And so I had a little help, but yeah, that was.
Yeah, no, this is
We had
great.
to narrow it down.
Yeah, no, this is perfect. It's exactly what I just said. If you don't plan very well and you put in a fail-safe condition, eventually it will fail and it gets washed away. So great. So this is kind of the corridor that we're talking about. And so when we're looking at a cross-section of a corridor, it's not just looking at it from a hydraulic perspective or, you know, a flow perspective. We're also looking at it from everything we talked about, the enhancement of water quality, the floodplain terraces, as Mary showed in her example of the cross sections from HECRAS. When you start to spread things out and you give it those terraces, you're then lowering your velocities, you're lowering your shear stress values, which then allows you the opportunity to have more vegetation, have different types of vegetation, more resiliency, less erosion potential, things like that. And so, you know, to Bao's point, when we talk about corridor, it's not just what sees active flows. It's everything outside of that that also goes into the stream corridor, has an impact on the surrounding area. And then on the left side here, you can see, you know, leaving those spaces for trails, recreational components. everything that, users and people like accessing.
Which can be on both sides. It doesn't have to be on the left.
It doesn't have to be on the left side. You can put a trail on the right side of the channel. Thanks, Des.
Not in a while.
So again, just kind of boiling it down, that stream corridor is the area needed to protect and preserve the stream. Like Val said, it's not just the flow area. Because the area outside of that is contributing to that protection of the stream corridor. And then Troy talked about, when you look at what's failing in a natural system, we may see some localized erosion around a bend, or we may see the channel shift like we saw in the Marcy Gulch example, where the center line of the channel actually shifted, 10, 20 feet to the left. That's not always a bad thing. But it is a bad thing if you haven't given it the space. And now that stream is shifting and impacting a structure, impacting something else. But if you've given it that overall space, then those minor changes in flow path, in erosion, aggregation are not an issue most of the time. So how much space does a stream need? That's kind of the question here. So there's 4 methods. Typically, when you're looking at establishing stream corridors, one of them is shear stress. Does everybody know what shear stress is? Have a good idea of what that means?
Why don't you tell us again?
Okay.
It's not the stress of shearing your feet.
It's not the stress of shearing your sheep, which will be very stressful. So shear stress is a measurement that we use. It goes into the erosion potential. It's basically evaluating the surface and how that flow moves over the surface. It's the stress that's put on that surface. And so if you have high shear stress values, what that means is ultimately, if the material below can't handle that shear stress value, it's ultimately going to be pulled up with the flow. And so when we're talking about shear stress, a shear stress of 1 oftentimes is used as a good indicator of having low erosion potential. But again, it's contextually based. So, there's areas where you can go to a 1.5 shear stress value and still not have any issues. Again, it's contextual, but that's one way of doing it. The other is the bankfold channel width. So this is somewhat of a debated topic. Bankfold, active channel. There's a bunch of different names for it. In geomorphic principle language, the bankfold is often associated with kind of a 1.5 year return period event, where it's kind of that flow that does the work within the channel. So Troy talked about those lower flows that are actually doing that daily work on the channel and moving sediment within the system. That's kind of your bankfold channel width. And a lot of times you can find those bankfold indicators in an existing stream system. That's actually one of the metrics for, if you're familiar with the Colorado stream quantification tool that the Army Corps requires for some of the permitting. That's actually one of the indicators they want you to go out to, is looking at an existing system that's similar to your conditions, finding those bankfold channel indicators. And that helps to define what your active channel or what your bankfold channel width should be with your project. So that's another way of looking at how stream corridors can be developed. It's, important to note that's your bankfold, that's the small corridor within the center of or the small stream section within the overall corridor. So it's helping define a piece of it, but it's not the entire corridor itself.
I'll just add here, so for bankfold, there's a relationship between the bankfold width and the meander belt width, which starts to set up as one corridor. And so bankfold width, the way that you establish a corridor is using the width of the bankfold low channel. It establishes the width of the entire stream. So it's that relationship. There's geometric relationships between the bankfold and the stream corridor width. That's how you would establish the stream corridor from 1. If you know the shear stress equations are very simple, the unknown there is really shear stress and your width of your channel. Since we've given it shear stress, it automatically solves for the width of the channel.
Yeah, that's a good point. Again, if you're familiar with the SQT the stream quantification tool, that's how all of those parameters are defined or related. It's taking that width and that depth and using that in the calculations to help determine what your encroachment depth is and all the other geomorphic parameters within the tool. So, yeah, it's a good point. Historical or similar basins. So again, this is looking at stream corridors that are healthy and stable, that are similar in your basin characteristics, your size, all of those metrics that we've talked about, and using that as sort of a guide to figuring out what space is needed for that corridor. So in a sandy system, you can go look at a healthy sandy system, and that channel is moving all over the place, especially if it's a steeper section, effective slope, because it needs that space to be able to find that equilibrium. So if you have a project in a sandy system, you can go to a similar basin that has those characteristics, see how much space that needs to be healthy. You can use that as a guiding metric for your corridor as well. And then the landform and topographic constraints, that kind of goes into all of this, but you know, obviously how your existing landform and your existing topography is oriented is going to dictate how much of the stream corridor is available. And so this is, again, like sediment transport, there's 4 or 5 different calculations you can do. Same thing here. These are all different methods that you can use to help define a corridor. Not a single approach is going to give you the correct answer in a sense. You kind of have to utilize all these methods together to figure out what the best corridor width is for your particular project. Again, guiding principles, this isn't the end all be all metric. So, example of a narrow and squeezed channel uses concrete versus, you know, giving it a wide and spacious corridor to allow for some of that meandering to integrate the vegetation. And this is where the idea of lower maintenance comes in again, where, you know, we're trying to find that balanced and practical approach to the corridor that, with the context in mind, is providing a healthy lower maintenance system. Not all stream systems are created equal. You're not going to have one system that is super healthy in one condition and then be able to use those exact same metrics and design for another area. You know, it just doesn't work that way. And so I like this slide. It may sound like hydrology. It kind of is a guess in a sense, but it's not, right? A lot of this is backed by data. There's a lot of modeling that goes into evaluating your overall basins. There's whole schools of thought on stream networks and stream corridors that I think Troy will probably go into more detail in a future class when we start looking at examples. But so it's not purely a guess. I mean, there's a lot of backup data that goes into this. It just takes the willingness and the time to evaluate it and go through the process.
So I'll just add, I'm going back to that question earlier that was asked. These are the set of calculations that you really want to finalize at the end of it.
Yep.
For a T2 to T4, the calculations for a T5 to T6, the urban is going to look different.
Right.
Just because you're working along really between the right window.
Yeah, exactly. And that's where also your lower maintenance is going to be different, right? If you have an area that has much more space, a lot of vegetation opportunities, that maintenance regime is going to look different than an ultra urban corridor where maybe you do have to do concrete in a portion of the channel, but you could do it in a way that is lower maintenance, that works better with the system. So, you know, I think the district has done a good job over the years of trying to get away from calling something low maintenance, because nothing is low maintenance or no maintenance, right? It's just contextually based on how how it's operating and what context. So again, with those 4, it's just blending the science behind it with the practicality of your area, and that is the planning phase. So that's everything that Brent was talking about. So here is just an example of how these widths can vary, even in tributaries that are right next to each other. So, you've got one on the left that the bend width or the meander width is, 210 feet. You've got one in the middle that's 480 feet, and then one that's 240 feet. And you can see these drainage ways are all next to each other. And even with that being the case, there's still a variation in that corridor width that you would need to provide in those areas.
If Troy were here, you'd say, this is out east in Aurora, starting Aurora, you'd say, because a lot of the areas out there have been impacted from farming or grazing. But you would say the topographic signature, even though the channel itself has been altered, the topographic signature, what the land is telling you, can still tell where that historic meander belt or the historic.
Yeah.
That's what he's illustrating here. You might go on the ground, and you're like, oh, where'd the channel go? Because they farmed here. But if you were to look at it in terms of historical era imagery, you can still kind of see the border that channel used to run.
Yeah, I just had to try to explain this yesterday during a meeting where, the client who's not an engineer at all was saying, well, we've never seen a flow that high, so why do we have to do this? Or why do we have to do these improvements? We've never seen flow. And I kind of had to explain this thought process to them of, well, part of it is a floodplain regulation. That's kind of the driving force of it. But also just because you haven't seen a rainfall event in the last 5 years doesn't mean that, when you do have that event in the future, you're not going to have issues, right? And so it's that practicality. And that's where us as, ambassador, we have to do some of that education component with our clients and with people that we work with. Because they won't understand, well, why do I have to give it 500 feet? It seems excessive. We kind of need to help educate them and explain this to them so that they better understand, what the intent is and what the goals are. Yeah, go ahead.
And something else to consider is when you have a historic path like this, and you regrade a site, move the low point of the site, and it doesn't fall anywhere near here. Groundwater conditions that were established over millennia are still going to exist there. So I've done a number of investigative projects where someone says, my neighbor has no problems at all, and on my sump pump is running constantly, and my basement is full of water. And I pull up the historic map and I go, oh, you're right in the pathway of a major drainage way, but it was regraded. So instead of the low point following historically, it's over here now on the street or whatever. It doesn't change what nature has created, unfortunately, underground.
Yeah, that's a really good point, and I'll kind of repeat, just summarize, but when you develop a site and you're moving away from a historic drainage pattern, oftentimes the ground, well, I won't say oftentimes, all the time, the groundwater is delayed, right? Because water moves to the ground at a much, much slower rate. And so just because you move a stream from a historic pattern to a new condition, it's going to take potentially years for that groundwater to reacclimate to that new stream corridor system. And so you may end up with issues or examples like you just said, where you've developed this site and half the neighborhood is directly through the historic flow pattern. So they have some pump issues, where the other half, where the actual stream now is, doesn't have any issues. But in 10 years, that might reverse, right? Because now the groundwater has reestablished, it's moved over.
There could also be soil issues with that as well.
Soil issue,
right? So you have cobble underneath and that's the flow path underneath.
Yeah, exactly. And then relating it back to what I mentioned earlier about trying to preserve as much of the natural space as you can. One of the projects that I'll probably show a lot through this class, we moved the stream 300 feet north of where it was because it was the stream was basically through people's backyards. There was like 15-foot cut banks, things like that. So it was a major safety issue. So we moved it away from the neighborhood. But in doing so, we actually killed one of the 2 cottonwoods we saved on the project, because after 1.5 years or 2 years, there was no more groundwater. The cotton, even though it was a big, healthy cottonwood, we changed that hydraulic condition within the groundwater, and unfortunately, the tree didn't make it, and ended up being cut down. So just things to keep in mind, you know, when you strive to preserve some of the natural conditions, you also have to keep in mind with what you're doing with the groundwater system.
You're also supporting about 500 new cottonwoods.
Yes, yeah. Right, and that's kind of the balance is, you know, we have this one really healthy 50-year-old cottonwood. Do we save it? Do we not save it, knowing that we can also plant 50 new cottonwoods? Or we'll get 50 new volunteer cottonwoods, things like that.
It's the politics of the upfront during the project.
Exactly.
That's those things.
Yep. Yeah, there was a Wonderland Creek project in Boulder. There was an uproar from the community because it was a choked down channel that was just full of trees and vegetation. And one of the first things that we had to do was come through and basically cut it all down. And there was an uproar from the community.
Yeah, and I'll point, that's because there was deferred maintenance. We end up with these overgrown channels because we never maintain them, and then people get attached to them, and it's in a state that is not beneficial. And so, you know, if we in Wonderland been going through and just trimming and thinning all along, no problem. It's not no maintenance. Pardon?
Birds get attached.
Birds get it, yes, birds do get attached. You have to do it in a certain time of year.
Yep.
Yeah.
So, again, give them space. A couple quick examples. So this is Harvard Gulch. You mentioned this. You know, this is an area where it's extremely confined. On the map, the blue is the floodplain, the green is the floodway. And, you know, so here through this section, there is a wider corridor, whether that was intended or whether that just was happenstance because they wanted to put a park here. But there's more space allocated to the channel through this system. You go a mile downstream, and now we're in a concrete lined, almost vertical walled system with fence and properties lining the top of the bank. Where you can see what happens to the floodplain. The blue expands quite a bit because now you've choked down the channel, so water has to go somewhere. So all of those properties are in the floodplain, and then the floodway is more confined. But I would argue that this comes with a whole host of issues compared to when we can just give it space. And unfortunately, this is a really old neighborhood that was developed a long time ago. And so in order to fix this would require a lot, you know, property acquisitions, things like that. So that's the importance of planning again, too, is knowing that this is coming 50 years down the road. So just a quick, I won't read through every one of these, but so this is actually the project that I was talking about where the existing corridor was to the very far right of that image through those backyards. And we actually shifted the whole thing about 300 feet over. But when we're talking about planning for space, so again, maximizing your space allocation for the network, using the site to manage stormwater before it even gets to the corridor with swales and other techniques like that. Using the natural topography to your advantage, and then using the space to bring in all of these other elements that we're talking about. This project was a huge economic catalyst for the city of Westminster because now they have an RTD system, they have a park space, they connected the south side, which was unincorporated Adams County, to the city of Westminster. So it was a huge economic driver.
And it's a big detention facility.
And it's a big detention facility. This is at the bottom of the watershed. So, you know, this is a huge regional detention facility as well that we were able to integrate recreational components into. Planning for flexibility. So this is what Brent was talking about, you know, when you're going through that planning process, knowing what is a constraint and where you have the flexibility allows you to come up with solutions like this that, you know, are more efficient and help maximize your use of space. And then planning for cost. Mary got into this a little bit with her slides, but if you're able to distribute your stormwater management throughout the site, you're reducing the size ultimately of those end of pipe treatments. So rather than a massive detention pond at the corner, you're now distributing that treatment throughout the site. You're reducing your pipe costs, reducing your infrastructure costs. Again, using the existing topography, it's much harder if you just come in and you scalp an entire area and change the entire drainage pattern. It's much harder to manage it. We end up using a lot more infrastructure to do that as opposed to just using those natural drainage ways, historical drainage patterns.
That planning the costs. One.
Yeah.
On this, but I think Kelly from Denver would know very well that Harvard Gulch example that you showed.
Yeah.
That 40 foot versus 125 feet. There's no way for us to solve that 40 foot.
Right.
The solution is everyone that is now on individual homeowners to protect their homes from floodplain because we can't reclaim space to give Harvard Gulch space that we need. So when you squeeze it too much, now the risk is really unmanageable.
Yeah, so I don't have any slides on this. It's just kind of a conversation here, but we talk about balance. A lot of that balance is risk management. So when you're evaluating sites, when you're going through that planning process, really understanding what risks there are and what potential, risks maybe you can take with a project in certain areas that lend themselves to the 5 elements and to providing more of a benefit. It's kind of that sort of cost benefit, risk benefit analysis of evaluating, we can put park structures, playgrounds, things like that in a floodplain, and it's relatively low risk if they're out on the terraces because, it may only see a flood event every couple of years, if that, right? And so that's a low risk benefit to the corridor by providing that recreation and things like that. The Harvard Gulch, not going through that planning process and not evaluating the larger stream corridor, we've now, over time, created a much riskier, much higher cost of failure in that situation just by not understanding what the risk management is for the project. So just something to consider. I don't know if anybody has thoughts on risk management or examples of maybe where you've evaluated risk intentionally within a project.
I've had projects where we've set a stream management corridor without factoring in that, like City of Aurora, for example, has regulations about they have park space that has to stay out of the 100-year floodplain.
Yep.
So if you design a stream management corridor that contemplates park elements like you're talking about being outside of the 10.
Yep.
Playgrounds outside of the 10, certain infrastructure out there, but once you have to take it out of the 100, it chokes the channel down significantly.
Right.
That makes it really hard to manage a reasonable floodway and floodplain that you have to keep an entire section out of the 100-year in order to confine linear park with roadways and all that stuff on the outside. So one of those big points to Brent's is like really thinking hard about whether it is on the municipal side, whether it is actually advantage to keep some of these things out of like the 100. That's a big one.
Yeah.
We have one in design right now with us, put our playground in the 100-year. So yes. And so we've got it designed so if it floods, this liner looks like a fit for swimming.
Yeah,
So it would be,
that's awesome.
I'm hoping it was, so we can take pictures. Not really.
Yeah.
Whose kids will be the riding?
But that's a great example. You were able to utilize the space to actually create a benefit.
We've also got cattail things that will pop out of the flood too, so it'll look like.
Yeah.
I think it's gonna be cute. Yeah.
It's great. As an engineer, some of the funnest work I do is like with landscape architects about like, what can we put in this detention facility that's regional and not gonna fill up very often, granted there's maintenance happens, but like, what can we do in the 10, between the 10 and 100? I understand keeping stuff out of the 10, but frequent safety issue, but like, what can we do between 10 and 100 with like a lot of space that's out there?
Yeah.
And a lot of times the elevation difference between the 10 and the 100 is not that much.
Right.
The 100 might mean a foot of water.
Yeah.
You know, it's not that much. And I also wanted to just pick up on something, Bennett, that you were talking about. The difference between the floodway and the floodplain is huge. So Aurora, for instance, their requirements to keep everything out of the 100 unit. You know, that sometimes has huge implications for our developer partners who are, they literally could be putting a lot of their open space into a floodplain. And the floodway might be, you know, far away. So that difference alone can be significant.
Yeah, so just this, using this as a visual, the green being the floodway, the blue being the floodplain, if you're required to stay out of the blue area, I mean, you've just, in this example, you just, you know, eliminated, I don't know, 200 feet on either side of the floodway to where you could put stuff or where you could put some of that infrastructure.
It raises, I think this is a good conversation. And I think we just have to go back to the why.
Yeah.
You know, when we're having, because I've had these conversations with, so with park and building space, or with the governments. And I think they have a legitimate why, and then once you know why, then it's how we can navigate it. I think most of park and open space experience with us as stormwater is they've experienced some of our poor designs in the past, let's be quite honest with you. I mean, you look at the bathtub design that's gone in, and we promised them that it's going to be good for program spaces, that we can use that for a lot of their programming. And they come to find out that they can't actually use it because it, like you said, it stays swampy and muddy, and we've got undesired vegetation. And so it's those experiences that's resulting in the really immediate no. But if you go back to the why, and their intent is we do want this space usable for a good majority of the time, then we can have the conversation that you and Jess just had, which is, okay, now understanding that, well, how about we design the facility, the detention facility, whatever it is, so that maybe it's the 5 year, maybe it's the 2 year, maybe it's the 10 year, we can have that conversation. But I think starting with why, with the no, helps to understand what creates that resistance. And it's been very, I would say for me, it's been really enlightening. To learn, okay, yeah, you've had those experiences and consistently, so now we have to give them new experiences to replace that so that we get to meet.
Jesse's point between the distinction between floodplain and floodway, I think it's important to.
Yeah.
Like, working out in the fringe is, at least from an engineer's standpoint, like significantly different than working in active floodway.
Exactly. And that's where, you know, discussing those risks and that risk management, you know, with whoever you're working with is very important, because out on the fringe, it may be in the floodplain, but it may only be 3 inches of water that moves at half a foot per second, right? And so your risk there is much, much lower than in the channel where you've got 12 feet per second, things like that.
I think that's a good point with like general public and how you sell this to them, because like you're talking about with the playground being in floodplain, they say like, oh, my kid's gonna get washed away. Right? They may not understand that you're saying, well, it's 6 inches of water and it's not even moving, it's just sitting there. And this is only gonna happen during a large storm event when your kids aren't gonna get out playing. So.
Right, yeah, with those large events, really nobody should be out there. Anyways.
Judging my parenting.
I'm not saying that.
Your rain jacket on.
Yeah.
That's why you have it.
Yeah. Laura, anything online, just to point out?
Nope.
Very quiet today.
Okay.
We're just gonna take a very quick, it says 10 minutes, but you have 6. So if you can be back at 11:10. Yeah, take a few minutes, stand up, eat some fruit.
Everybody has to take one look. Yes.
Is the clicker?
Okay, we're on.
Mary, I think you
There, is the clicking? We're live? We're live. Can I?
Try it.
I do.
Go to, that makes it this one. Okay.
Oh, there we go. Got it.
There it is. So we shaped tomorrow, right?
Shape.
Yeah, we shaped it. Now we're gonna talk about dynamic teams, so multidisciplinary teams, to be exact. These designs that we're talking about really do take a team, and it's complex because it involves ecological, social, and engineering challenges that we've all talked about. And then the collaboration across disciplines is crucial. But when we do have it, it can really enhance the project a lot. And from that, we can develop community sometimes in these projects as well. And that also helps with the long-term sustainability. So we go to the wheel of the elements. And I like to look at the wheel and say, well, there should be a different consultant or team member for each of the elements on that wheel. And so it'd be an engineer, geomorphologist, an ecologist, and probably a landscape architect. But a lot of times in some projects, depending on the context, you could be missing somebody that could be crucial to that team. And I like to think of it, who else could be there that could add to the project? We don't want to just add bodies for no reason, but an urban planner is always somebody that can be helpful to that project. Social scientists, we look at public engagement on a lot of these projects. It takes a good team of somebody that can really engage that public, and that takes work. The public isn't necessarily always there to volunteer their time to add their input. And then policymakers, how are we integrating our elected officials? How are we integrating our stakeholders, our outside stakeholders as well, that could have a real role in how this project comes to life? When we have a multidisciplinary team, it can add a lot of benefits. And it does add a lot of benefits. I've seen it from personal experience. Do I have to click to make that play?
That play?
There it goes. It's going. It's going. It's going. Perfect.
At least it's not.
So this is Kenny Drone, actually in Golden, downstream of the project that we had talked about prior. This is actually at the Coors Brewery. Coors was doing a huge expansion, and in order to get that done, they needed to address their floodplain issues. So if you've ever been to the Golden Mill, this is right across the street. But this was a large team of individuals, including the developer who was Coors. And then landscape architects, engineers, geomorphologists, ecologists, to really make this work. I think it is an improved trapezoidal channel, really, in context. But this is really the only way that we could solve this issue. We did integrate a lot of pedestrian access and making connections. That's what we saw on the front side. But we were, introducing placemaking strategies. There's a streetscape now involved. And from an aesthetic standpoint, it's way better than what was not there prior. From, comprehensive planning, we probably need to integrate more ecological ideas into those. But we're also looking at economic and social factors when we're looking at some of those. And then another benefit is efficient resource use. If we bring in the right team members at the beginning, we can really plan for unforeseen circumstances that we might see.
Brandon, I'd like to really maybe bring back the point about the things that we're often missing, which is the public outreach piece. How many of us in this room and maybe even how many online are public outreach specialists? Anybody from the social sciences here? No, and it's because, and how many of us really enjoy the public process and are good at it? Right. So,
No hands are.
no hands, that's a big, not,
Is there anybody online that has their hands raised? No.
I doubt it. And I mean, to me, it's a real, what it means is that we oftentimes are working in a vacuum. We come to a community with the solutions we think they want. We come in knowing the answers. We might put up a couple posters and ask them to put little dots on it. But we're really missing the opportunity to have meaningful input from the public about what they want, what they need, what's important to them. Do we always get to solve exactly everything that they have? No, but I personally have been involved with projects where the public involvement changed the outcome in a beneficial way, such that there was not, like Brent's example with the platform project where the public was so involved and they got an amenity that was important to them. So anyway, I think it's our weakest point in the industry, I think. And we can do a lot better. I don't have any answers on how to do that, but just there are people out there that can spend, and it's especially important early on, you know.
I think that the beneficial outcome of having the public engaged, especially Flat Farm, is they've now taken ownership, right, of that spot. And if somebody were to do something to the benches or any of the things that they wanted that are now out there, they would probably find them. And, but like, they are taking care of it. They see it as their park. And so that's a large beneficial use to having the public engaged early, and within these projects. Like I said, we've worked with a number of companies that have helped us through that process, and it's invaluable.
And I think that's even more important in some of these T5, T6 areas, because a lot of times people, you know, they could live a block away from the South Platte River and not know it, right? Because of the buildings and because of things that are blocking their access to the river. So they don't even think about it. But if you can get them access points, you can get them engaged with the river, they're gonna treat it like it's theirs. They're gonna protect it better, you know, so, you know, hopefully that means there's less trash going into the inlets. There's less, you know, I don't know, things happening that impact the corridor.
It helps to explain the why as well. Why we're doing what we're doing. We're not coming in and cutting down trees just because we want to. Really. I get that a lot. You just want to do a nice spot. No, we want to make it better. I'm trying to make it better, and it's hard. It's a hard thing, and it's not easy. But going to the public has a lot of benefits.
I'd love for you to speak to this. I think such a great point here. Public engagement, but how we do it so we get the right people there is also a challenge. And I think that what you guys did out of the First Creek Park project, the one we showed here, I think that you actually constructed an activity.
Yeah.
So that really the right people would show up, so that you got the right input versus those are just onto the project.
Yeah. So that project, we brought the kids in to help design the project and say, well, what do you like most about this space and what can we do? And Cassie in our office really took a lot of that input and really added it to the project. And so we'll show some pictures later on in another class, but making it so that the kids can interact with the water is huge. Everybody's drawn to the water. Humans are instinctively drawn to water, and making that accessible to everybody, especially in a neighborhood like that, it's incredible. And it's highly used project. And again, that public engagement process on that one was was a little bit more hands-on. And, everybody that came out at the end was saying, this is exactly what I want.
To remember, looking for, looking for wildflower,
Yes,
right?
yeah. And
Because that's what
maybe-
you wanted out of the product.
yeah, she wanted flowers and she wanted every, there was a lot of that. It was great. Any other thoughts here?
From my perspective, I'm seeing these changes. It's new for me, to Mary's point, that I'm not a social scientist. I'm about as engineers and engineer gets. Headworks, but the Weir Gulch project that we're thinking about right now has a ton of community engagement. front loaded with it. It's a new experience for me.
Yeah.
And you're.
Yep, Cassie's involved.
But like, it is a completely new experience for me as an engineer to be involved with that on the community engagement and going out to this urban, T5 kind of area before we try to make improvements to them. Front load and what the community wants from it. I'm excited to see how that turns out. It's gonna be incredible learning experience.
Yeah, and they're
For sure.
trying some new things there too, and maybe I'll have something to report here. Once we get a little bit further, maybe into the summer as well. We can talk about that, but, we'll see. The new things that they're trying are interesting.
Out of curiosity, what's different than, like, I'm used to the dot on a paper, like, what are some of the things for your time?
Oh, you can go first, obviously. I choose that, but
Yeah.
I have.
Well, on this one, they are, getting training on the front end, with the engineers, the landscape architects, ecologists and all that. To, really train them on how to talk to the community and how to interact and actually, tell the story of what, the project is. And how they can come into a community where they might not be as accepting. Because, we're coming in with a huge project. So how does that interact with an established community that doesn't necessarily know exactly what's in their backyard?
To say, I found that people have enough meetings to go to and don't want another scheduled meeting. So instead of scheduling project-specific meetings, going to the already scheduled meetings and giving a heads up, this is happening, getting the word out, at these, like going to the community instead of expecting it.
Yep. And one time.
Yeah, I'm just gonna say, like, this gentleman,
That it?
also in the water program, we've seen each other on Zoom. I think it's going really well so far. The consultants that have been involved with the communication have done a really good job, and they've also been very good with designs on how we're going to kick off certain levels of that. And then the first, actually, I think their very first open house that they had, I think at I forget the name of the ponds, that's all Sheridan. The community response was like, why have you done this sooner?
Yeah.
It was kind of interesting, right? Like, that's the response you want to hear. So it's like, it does work when you present the message well.
Yeah.
Yeah. I was just gonna say, on your point, to go to the meetings, we've also had a lot of luck. Having a meeting where we offer childcare and give people food.
Yeah. That's a good drop.
Online, we had a note about don't underestimate the passion and knowledge of the public stakeholders.
Absolutely. Again, they're the ones that are there all the time. We're the consultants that are coming in and doing the work and not necessarily flying out, but they're gonna be there for a lot longer than we are.
We also had another note, engage stakeholders early and often. Charlie's experienced empowering the community members to be ambassadors for the project. And that's been well received. More people are willing to come to the table and provide meaningful feedback when people from their communities are helping to drive the process.
And so that's another good example of what we've done in the past as well as the ambassador program. We've done a number of projects with them where they go in and find youth in the community to help steer the public engagement and then also steer the design. And there's been a lot of good outcomes from that as well, which is pretty new. So in the planning process, early collaboration identifies challenges and opportunities. We have cross-disciplinary data collection and analysis. We've done this prior and we're doing a little bit more in our USAP site analysis tool.
And what is USAP?
Oh, urban stream assessment
Procedure.
procedure protocol.
Process.
Something.
Yeah, and that's going out there and looking at a stream from the 5 elements and giving the stream a score. And so you're assessing a pre-project level and then hopefully a post-project and maybe in a 5-year or 10-year post-project, which is a neat little tool. Community engagement, like we talked about, scenario planning, adaptive management strategies. How is the project going to play out in the future? How are you planning for those future externalities, if you will? Early identification and regulatory and policy compliance considerations. So Mary's team with the permitting, are we looking at what we're going to be required for a project from a permitting standpoint? Yeah. So, any other questions or thoughts about multidisciplinary teams that I'm missing?
Just from the planning part and the community engagement, how set yourself up to quantify the success of that?
Well, I'll jump in.
Yeah.
2 things. One, I think we're also trained to believe that community engagement is like right at the beginning and that's where it stops. And so it's just like we're talking about engaging our consultant partners early and often. We're engaging our stakeholders and our maintenance people early and often. We're actually going back to, and Denver's actually doing some of this now, but we're going back to the community and saying, how is this performing? How is it working? Is it meeting some of the metrics that we set up for you? And I think it's important to just not, if you can do it, and this is, it's like turning a cruise ship, right? But if you can do it, you're going back and asking, did we succeed? Where did we fail? What can we do better next time? Because then the end of that engagement, when you're evaluating one thing, turns into the beginning of the next one. Hey, what we learned on the last one was this. And so we're already kind of hitting the ground running on the next project. So that's something that I think is important, but it's, as Mary said, I think that a lot of our processes have gotten stuck in the old, we're gonna do 2 public meetings, we're gonna do, and the way that we are engaging our client and communities now is very, very different. We're getting in their living rooms and we're getting them and talking to specific groups about what's important, not only for now, but what's important for their mission. A lot of these organizations, take a cycling group, for instance, they might have a mission that you didn't even know about and that you can start to address. And then they become your advocates. So getting back to your question about metrics, you can then go back and they're your advocates and they're giving you that data point. So those are just a couple of thoughts that I have.
I think we need to be prepared for potential legal challenges to projects. At least we've seen, remember what that. So, okay, where you turn when someone goes that direction. Have access to legal representation on behalf of what you're trying to talk to their people. Very necessary in a field of projects.
I've noticed a lot of projects are, I don't know, for the online folks, there was a comment that we should be more prepared for and planning for better legal representation or legal challenges. Did I summarize that?
Potential.
Potential for it. Thank you. That, I think that is one of those, we've been seeing a lot more of our municipal and governmental contract projects leveraging outreach that has happened in prior planning phases. So we're, sometimes you get this, like, we're not gonna expose the community on this phase of the work because we're just planning. And then they're going back to the community later when they're trying to make improvements. And it's like, well, wait a second, how come we didn't know about this or, whatever. So shifting some of that to the front end, where you then have a process that you're engaging with the community and the stakeholders that you can then lean on later and say, well, we actually did have a process. Here's who weighed in. These were big decisions, and we're going to continue this process. But we have a foundation now for some of these things that's a little bit easier to defend rather than coming in with like, oh my God, you're changing my daily life. That's usually what people are responding to is, you're making, you're changing something now. Oh my gosh.
And to add to that, Jesse, documentation of our process. We've been doing that a lot more with our story maps as on our project. So as we're going through the urban stream assessment procedure, we are, adding that to a website where people can access that and have those documents that this is the reason, these are the whys, this is why we've been moving through that. And I think that helps to manage some of the risk, not all of the risk associated with the legal challenges that we can see. Everybody, Leah?
You literally took the words out of my mouth, Jesse, with what I've been trying to do at my work is trying to use the prior planning phases and local agency plans to inform our public outreach, so we're not like reinventing the wheel with every NEPA project. And like NEPA, those kinds of cases are like notorious for, because they're supposed to involve public, but they're also, those projects are run by engineers who aren't trained to work with the public. And a lot of times, like with the Floyd Hill project on I-70, outreach was done to the local communities, but who uses that corridor? It's the entire state. It's like the whole country. I possibly reach out to everyone who's been impacted by that project. So it's like, where do you draw the line? Like, when you stop doing outreach? That's a challenge.
Yeah, and I think, a lot of that is comes back to your partners too, because, we do a lot of community outreach in our practice, but we're partnering with people who are better at it, people who are, that's their everyday. Sometimes we're partnering with 2 or even 3 partners because, to your point, somebody might have some really good grassroots connections in the community, but they're not maybe the right one to be coordinating with CDOT. And so I think we often forget that engagement involves all of these stakeholders on a different level. It's not just, community engagement is usually like, it's this quarter-mile circle or maybe a half-mile circle where the postcards used to get mailed, right? Or whatever.
Yeah.
So it's really rethinking all of that. And I'm glad we're spending a lot of time on this. I don't know how much more you.
No, this is great. That's kind of goes back to this comic that I have up here. There's really knowing who to call and when to call them. You can't do it all yourself. That's why we have teams.
The last one should be a thought bubble because we would never say it out.
Yeah.
There's too much eye contact.
Catch me on the right day.
I did want to circle back to something Brent alluded to, and that is that we have this really, there's some good things and some maybe not so good things about the way technology has changed the way we're interacting with people. I will say one of the good things I think, and you alluded to this, is the way that we're able to document visioning processes and marketing processes and engagement processes now with online tools that can be controlled for, the South Platte Needs Assessment had 2 different windows. It was like the window that Denver can look at internally, which has a lot of data, And then it's got the window that everybody can look at. And they can control that, right? And you can build on that. So you're, like Brett was saying, if we do a story map for something, that story map can live a long time and it's accessible by a lot of people. Where you have communities, you know, like in Weir, you have communities, you have people who have been there for generations. And so they have memories, you know? And then there are other people that are new and they don't have a memory. And so you can really start to bridge a lot of that knowledge and a lot of that past work and help establish foundations for what Debbie brought up, as well as just build on rather than reinventing the wheel every single time. So I think that's a positive thing. There are negatives that I can speak to also, but that I think is a.
I think it's a real positive, and I think that the way that, you know, we talk about COVID a lot, but we've introduced and now it's being more integrated is the online version of being able to attend a public meeting. That allows a lot more access. And you can reach a lot more people. Again, good and bad, but at the same time, it's one less excuse for them to say, I couldn't attend the meeting. Yeah, other thoughts on multidisciplinary teams? We need to hurry. So we talked about these a little bit. Common officer
Card or the yellow card?
I'm in a blue card, I'm halfway, okay. Common obstacles, communication, of course, competing priorities, funding, perception of time. We add more people, it's gonna take more time. It's always what, or it's gonna cost more money. Not necessarily. Strategies for success. We wanna have clear roles within our group. I would say stay in our lane, but a lot of times that's a little gray. Regular interdisciplinary meetings. So we're meeting a lot more often, but that also has greater advantages for the project. And then really having those shared goals from the beginning and really revisiting that. And we talked about project chartering, and I don't know if we're gonna, talk a little bit more about project chartering and how that works. But the flood district is doing a lot more of that.
I don't think we dig into that with the smaller information.
That's what I thought. So, and then stakeholder involvement. We don't have an exercise. We're skipping. Kind of wrapping things up and going back to systems thinking. We talked about this last time. But really, we're building on, there's multiple layers to urbanism and how that works. You have the environment, the economic system, and the built system, and how are we integrating it all together in a city? Systems thinking views cities as interconnected networks rather than isolated parts. And that's kind of everything we do. Everything is all connected. Talked about that a lot. This slide really brought on a lot of conversation last class too, about the resilience and adaptable urban environments. There's a lot of discussion about that adaptable word. And I thought it was good. Any thoughts on this? We have more conversation. I don't know. We talked a lot about context, and context matters within the transect. What is successful urban planning? When we start urbanizing an area, we must remember that humans exist within a broader landscape. We're part of not only in our neighborhood, but regional and a part of the world. How are we doing? How are we developing an area, thinking about the future? Talked about context a lot, geographical, cultural, the existing conditions of the site, and knowing that the context of an area could lead to indirect costs, those externalities. So from a stormwater management side, thinking about sites regionally, within your neighborhood and then also, actually on that site. Understanding how streams and ecosystems function, we can design solutions that solve multiple problems at once. Maybe there's a connection that we can make through our site, or, an added benefit, an added value to the community. And our actions have long lasting impacts. And we're talking about weird. We've put ourselves into a corner on that. The repeat. Let's just say it twice, yeah. And then I also want to end that nothing happens in a vacuum. Our actions ripple further than we think. And this project is one of them. This is the Eco Park in Arapahoe County. And these kids take this pathway to school every day now. And there is a bridge just upstream, but they take this one because it's a lot more fun. It's a fun site, and those little things, those little value adds to a project can make all the difference in the world. Oh, have you allocated this for the future? Yeah. I think that's it.
Almost done. So just a quick recap of today. We started off this morning looking to nature, looking at, oh my God, this was like a week ago. What did we do this morning? High functioning, low maintenance streams.
Yep, a lot of distributed, recurring functions.
Recurring functions, lots of looking back to the criteria manual, green infrastructure. Shaping tomorrow, we learned about how to plan, what the planning process is, incorporating the space early. So looking for that line of where the space of the corridors, the green infrastructure you learned about first, how to plan for that early on in that concept planning phase, hopefully plat and plan. Well, lots of P words. And then we finished up with just dynamic teams, multidisciplinary teams doing things together and bringing in people that may not be at the table. I know in our first class, we asked everyone to think of a project and talk about who might be missing. We got all kinds of interesting answers. Geomorphology folks, community folks. I remember somebody said, I think science was missing, stuff like that. So some good things to just think about as you move forward when you're starting a project. Who's missing? What's in your way? How do you get them there? And that concludes our content portion. I have a few logistics for you before we all, go on our merry ways and eat. And so, and then one quick, little bit of logistics, one quick question, and then we'll end for today. Okay. So we have been sending surveys at the end of every class. The folks online will get one. The folks in class will get a third and final, as Val mentioned this morning. Takes 5 minutes, really helps us improve. Folks online, you'll get a certificate of attendance. So for, is it for attending all 3 webinars, Laura? Okay. So if you attended all 3 webinars, you'll get a certificate of attendance to say you have been here. And the folks in class, at the end of the year, once we're done with all our other classes, you'll get credits. I believe we have planning credits and CASM credits in the queue for you at the end. So that will come much later, but folks online will get that in the next week or 2. Folks in person, our first field visit is June 26th. Make sure your calendar, we sent out calendar invites, but just make sure that's on your calendar. It'll be at Cherry Creek, I live to Quebec area. We will send all the where to park, what to wear. My son goes on a lot of field trips and they're like, wear the same color shirt. So if we can coordinate that, it'll make me super happy. Wear your orange color. Yeah, we'll go over together. It'll be super fun.
Also on sunscreen, water.
We're taking it a step further, Jesse. Okay, no, yeah, but we'll have all of the reminders in the, and then if you want to wear the same color, that's fine. Okay, so we'll send an email out about a week ahead of time just so you can prepare, but we
Same
will,
color with names in the back.
yeah.
right? Is that-
Team Stream is what it's gonna say on the front. Okay, am I missing any logistics beyond that? Okay. So, before we end completely, what I would love is for everyone, online, if you could drop one word in the chat about just what your takeaway, your one word takeaway from today is. And I'd love to hear from 3 people in the room. Your one word key takeaway, and then we'll hear from 3 people online. So 3 people in the room, one word takeaway from today. And if it's 2 or 3, that's fine. I won't be super mad. You get extra points if it's one word.
Space.
Space, good one.
Communicate.
Communicate,
Collaboration.
collaboration. That's going on the shirt. Space, communicate, collaboration. How about 3 from online, Laura?
Planning, communication, space,
Oh, you didn't-
multidisciplinary teams, very similar. So good themes, good themes. Contact.
Space.
Okay. Good, so space seems like the key takeaway. I think that's good. Awesome. Thank you all for being here today. Thanks for being in person. Thanks for being online. We'll see you all in a month or so, and we'll see you all online out there in the stream management world. Go forth and ambassador.
Fourth and Street.